Learn to use JavaScript and Kaboom.js to build a Metroidvania style game. In this tutorial from JS Legend Dev, you'll learn everything from setting up your development environment to implementing complex game mechanics, like enemy AI and boss battles. You'll learn how to load assets, define scenes, manage game objects, and more, all while creating a dynamic and engaging game world. By the end of this course, you'll have the skills and knowledge to bring your own Metroidvania game to life and deploy it for others to enjoy.
Hi everyone, welcome to this new tutorial. Today we were going to build a Metroidvania style game. So Metroidvania is a style of game where mostly they're usually platformers, and the difference between a normal platformer and a Metroidvania style game is that in a Metroidvania you don't have levels. You explore one big map, and some parts of the map are cut off or not available to you if you don't have certain abilities. So the whole point is to explore the map, unlock new abilities or find new items as you explore, and this will unlock certain parts of the map that you weren't able to access before. And here is the simple version of that. So here we have a little robot with a sword attack, and for now we cannot go to the right because we don't have the double jump ability. So as you explore the game, so here is a health pack. As you explore the game, for example, I go here. The goal of the game is to find the exit, which is, so basically if I start the game from scratch, you have this, escape the factory, use the arrow keys to move, X to jump, and Z to attack. So here, if I explore, you can see, for example, the second room, and there's something down below. We want to see what it is, so I'm going to go to continue my exploration. And here we have drones. So drones will follow you and self-destruct. So I'm going to teach you how to code that as well. So here I have, so just to show you a full overview of the game before we start building it. So here's the layout, etc. And now here I cannot double jump here. If I do, I'm going to die. So now let's beat the boss, which is going to allow us to unlock this ability. So the boss we're going to beat is this one. So as you enter the boss room, you cannot exit out of it. So that's a bit like the Souls games. And then this little boss has a flamethrower. And basically the way is we just avoid his flames and we hit it. So I'm just going to do this very quickly. And then after that, you're going to see that we're going to unlock a power-up, which is you unlocked a new ability. You can now double jump. And then here, I can go here. And this was previously inaccessible. It's a shortcut. And I should not die here. I just died. Anyway, the game will save. So you still have the double jump ability. And now that we have unlocked this, we can go back to where we couldn't proceed. And then I'm just going to beat this one. And here you get access to the second room. And as you see, the camera is dynamic. It will follow when the player passes through certain things. It's going to follow. I just died here. It's going to follow the player, or not follow, but just change angles and positions to better show the rest of the level. And that's the game. Now, to draw this level, to make this game, I'm going to use Kaboom, which is a library for making games in JavaScript. It's very easy to use. And so I'm going to teach it to you as well. So the prerequisite for following this course this tutorial is that you know at least the basics of JavaScript. We're also going to use Tiled, which is this program I have here, to draw our level layout. So because we're not using a traditional game engine, that means that we don't have access to a level editor like in Godot, and that means we need to use an external program for that. Otherwise, it would be too tedious to draw the level layout in code. So here, Tiled is a nice program that fills this gap. So I'm going to teach you how it works basically, but I will not go into too much details. So I'm going to teach you how this map that I made works. So these two rooms, what are all these colliders, etc. But I will not, like I did in previous tutorials, redraw the map from scratch and show you how it's done, because it's going to be too tedious to replicate the exact same layout. So consider these maps as assets. They're going to be .json files in the description that you can download, and you're basically going to import them into your game. However, I have written a guide, so I'm going to spend some time to explain how to draw maps in tiled at a higher level, but I'm not going to go in the nitty-gritty details for this specific project. However, if you want to have a written content, I have written recently a blog post on how to use tiled with Kaboom.js. So here's my Substack. It's where I write content. This is where I do written tutorials. So my YouTube channel is really a good fit for project-based tutorials, but sometimes you just want to know how to do a specific thing, or you want to reference something that you found in my tutorials, and referencing a video or a specific part of a video is usually tedious. So having a blog post nicely written like this is how I do things to like, I use this as well for myself, so I can reference back when I need it, how to import maps from tiled, how to use tiled, and then use them in Kaboom.js. So if you're interested, give me a subscribe here to not miss on future written content. So the link will be in the description. All right, so now for the setup, I'm going to use VS Code for this project, and I recommend that you also do, because we're going to use the live server extension, which can be found in the extensions marketplace, live server, and then install it here. It's written uninstalled because I've already installed it. And this allows us to start a local server for a project, and it's very easy. However, if you have your own setup, feel free to use it. You can start servers in other ways. One example would be through Python. You can start a local HTTP server with it. So let's jump right into the project. So I have my workspace here. I created a folder. I called it Metroidvania tutorial, but feel free to call it however you'd like. All right, so now I'm going to create an assets folder, and this is where we're going to put the assets for our game. So the assets are mostly coming from an asset pack on itch.io, so I'm going to provide the link for that in the description. However, there are two sprite sheets within that I'm going to replace with my own, and those two will be in the description as well. The reason I'm replacing them with my own is I just reformatted them so they fit better and can be imported in Kaboom easily. All right, so let's create an assets folder here, if not already. I'm going to also create another one, which is going to be the lib folder, which is where I'm going to put the version of Kaboom. So for this tutorial, I'm not going to use Node.js. I'm just going to use the simplest setup you can for Kaboom, which is just taking the JS file and then importing it into your project using native JavaScript modules. So if you want to use Vite, for example, or a Node.js based setup, feel free to do so. And if you're not sure how to do that, look at my previous tutorial where I made a 2D developer portfolio. This is where I used Vite and NPM. So you can just take the setup portion and then follow along with the rest for this tutorial. All right, so I have the lib folder here. I'm going to put later on the library here that I'm going to download. This also will be linked in the description. I'm going to create a maps folder, which is where we're going to put the maps. So the two .json files that I've shown you earlier here. Then I'm going to have the source folder, which is going to contain most of our code, an index.html, which is important because it's the entry point of our program, and that's basically it. So for the index.html, I'm just going to write the code, start writing the code. So I'm going to write the HTML tag, a body tag. It's not very important for a game to have this markup, to have a like really deep markup, like a lot of boilerplate, etc. So I'm just going to use a simple markup HTML body tag, and then within we import our script from the source folder. So I'm going to do .source.main. It's important to use a relative path, because if you're going to put this on itch.io, it uses relative paths to be able to load your game. So that's why I use a dot here instead of just writing the absolute path. This file does not yet exist, so let's create it. So main.js. And then here in index.html, we need to also add the type of it to be module. The reason we're doing this is because without this, we cannot use the import syntax. You cannot use import X from Y. This is called native JavaScript modules, I think. All right, so now that we have this, let's save everything. All right, and then I'm gonna import the files now. So let's see if this works. Can I just drag and drop? Can I do? I cannot. Okay, so I'm gonna have to do this differently. So I'm gonna drag and drop the versions. So here, what I like to do when I'm not using npm is just to have a simple text version that tells you where to get the library and the version of it. And here the .mgs file is what you need to install, to download. So the way you do that is you go to this link. It's going to be in the description, hopefully. And then you're gonna be brought to a page with random code. So let me just open it up. It's not random code, actually it's the code for the library. What you do here is you right click and you click save page as, and it's going to save it as a kaboom.mgs file. And then put that file into your project. All right. Now for the assets, I'm gonna do the same thing. So I'm just gonna import everything. So we're also going to have some sounds, by the way. Those sounds are free of use, but there's one sound that I put the credits of. So yeah, for the sounds, a link will be in the description as well. So the two sprite sheets that I've personally modified myself is the burner, which is the boss, and the u.png, which is the player. I had to tweak the jump animation and the placement of the jump animation, and for the burner I had to center everything, otherwise the character, the sprite sheet wouldn't be displayed properly. The animation were weird. Yeah, so it's a bit hard to explain what the issue was, but if you have the original and you try with the original, you're gonna soon realize the issue. We also have this glyph mess.ttf, which is the font we're going to use. This is provided by the asset pack. So everything here is provided by the asset pack in the description. But as I said, for burner and u.png, replace these with my custom ones. All right, so here you have the sounds, etc. Okay. Now let's go to the maps and let's import them as well. So there's four things. So I need to explain something here. So here room.1.json is the file basically with all the data needed to draw the map. This is from tiled. There's also room1.png and room2.png. And the reason we have room1 and room2 here is because in Kaboom.js, strangely enough, it is more performant to just go to tiled and then export the map as an image, and then just it would be one single sprite and display it as a single sprite rather than drawing every tile as in your logic from the sprite sheet. That's why I have exported both a room 1 and room 2 as PNGs, and the reason what the JSON is for now is just to know where the colliders are. So that's the use for that. So usually in game development libraries, you would just only need the .json file, and you can do that in Kaboom.js. You just need that and not you wouldn't need the other ones, but it would be less performant because the way you would draw is you would take your original asset, so your sprite sheet, your tile set here, and then draw from there. But for some reason in Kaboom.js, if you do that, it's less performant than just baking all your map into a single image and then just displaying it. So with pixel art, it isn't that big of an image, but you also need to think of the network considerations. So since this is a web game, maybe you don't want people to have to download two bigger images, and if you could only use a single small image, it would be better in terms of loading. But I think with games, people are more forgiving when it comes to these stuff rather than a normal website. You shouldn't exaggerate, but I think that's usually the case. You're usually more willing to wait a bit before playing the game rather than if it were a website that you need to use immediately. All right, now that we have that, I think we can get started with importing Kaboom into our project. The way we're going to do this is I'm going to use a file. I'm going to create a new file. I'm going to call it the Kaboom loader.js. This file is going to be the one importing Kaboom because, okay, so I'm just going to do it and then you're going to see why. It's going to make more sense like that. So what we're going to do here is I'm going to write an import statement. I'm going to import Kaboom from, and the nice thing with JavaScript modules is that you can just do lib. You can import the MGS file immediately like that without any script tags. So once you do this, so just the path is from the lib folder. So here we are in the source folder having ... That means we go up to the root of the project and then we go back in lib, the lib folder, and then kaboom.mjs. And then here I'm gonna have a constant. I'm gonna call it the scale. I'm gonna scale probably the game 2 times. I'm not sure actually if I use, yeah. This is going to be a fix around an issue that's going to come up later. So for now, just have this constant up as the scaling. And then here, export const k is going to be the Kaboom context. And the way you initialize the Kaboom canvas is by calling the Kaboom function and then passing it an object which contains a bunch of properties you want. For example, I can specify the width of my game. I want it to be 640, and the height I want it to be 360, and I want it to have the letterbox option to be true. So here, if for now nothing happens, but I also need to I forgot something very important. Global should be false. So global, the reason is by default, if you import Kaboom, you just can start using the Kaboom functions immediately. But what I prefer to do is to store the Kaboom context in a constant and here k, and all Kaboom function will have to be prefixed by this k dot, and then you call the Kaboom function you did. This makes the code cleaner, in my opinion. So now, so now if I go to main.js and import the, so I'm gonna import k. So import k from Kaboom loader, because we're using JavaScript modules and not using an npm based workflow. We need to specify the file extensions, otherwise it's not gonna work. So Kaboom loader.js, and then here, just by doing this, if I click on the Go Live button, which is at the bottom right of VS Code, you should be able to see the canvas being initialized. Now, one thing I want to add for this project is in the index.html. I'm going to add a bit of styling. I want the background to be black, basically. I think it's going to be better than white. So body, and then I add the background, not necessarily color, just background, and then black. And now if I go back and look at the result, you have a black bar. So we nicely see the difference between the canvas and the rest. Now there's one thing I wanted to do before, and the reason I had the scale here is because I want the canvas to be scaled as well. So this is a shorthand in JavaScript. When you have a property that is the same name of a variable, you don't have to do scale, not scale. You can just use scale like that as a shorthand. Now, and also I need to multiply by the scale here. The reason I'm doing this is that in Kaboom.js, the pixels, certain pixels can, it's a bit hard to explain. So I'm going to make a schematic. Excalibur.com. All right, so we have Excalibur, maybe dark mode here as well. Do we have dark mode? All right. So in Kaboom.js, and not necessarily only in that, but I've noticed it in Kaboom, is that when you have pixel art, so imagine this is 1 pixel, okay? And imagine that we have a drawing like that with multiple pixels. So let me just zoom in. It's not going to be perfect here. Okay, we have this letter, I guess. So yeah, so we have this letter. Or let's see, we have it as 0. Okay. Imagine this is a sprite. The issue is that in Kaboom.js, sometimes a pixel will take more space than a pixel, and you will have like a bit of padding like that, a bit of padding like that. And that means that this pixel and this pixel, in theory, like in the sprite art, should be the same size. But somehow, it's not the case. And this issue is not entirely resolved. So if I go back to the original game, is it working? Okay, I need to refresh the game. Sorry. So maybe you can notice it. So this is with the fix. Even with the fix, there's an issue. But if you look here, here, you see? You're probably not gonna notice it, but this pixel right here, I think it's better, it's more visible here. So maybe go full screen. This pixel is not the same size as this pixel, even though they're supposed to be the same. And this is something, a rendering padding issue, that Kaboom adds some padding, and this caused this. And this is the less worse variant of it. So this is barely noticeable, and it's barely noticeable because of the fix the hack I used here. But if, the hack is basically you set a scale value, which can be 2 here, you multiply your width, you multiply your height, and then you also set the scale as well. So this hack allows us to reduce the, to not have this issue, but to have it less visible. So it's something in Kaboom I didn't want to modify the source code itself, and even when I tried to fix it, didn't work. So if you're a Kaboom maintainer, maybe fix this, and that would be great. So yeah, so maybe you cannot unsee this anymore. So yeah, sorry, sorry for making you notice something like that. All right, let's go back to to the project. So now in the Kaboom loader, the reason I call this the Kaboom loader.js is because not only we're going to load the Kaboom library here, but we're also going to load our assets from this file. So in previous tutorials, I would use a Kaboom context and then just have this one and then do the loading in the main.js. But I thought to have everything that relates to loading things from Kaboom to be in the Kaboom loader file. All right, so let's load the various assets we're gonna need. I'm trying to think, maybe it's not the best to do this directly. I think we could do, if we do this once and for all, and then we won't have to worry about anything related to animations. So this is something that is very tedious to do. I would recommend that you just copy and paste the source code. So by the way, the source code is available on GitHub. So this is something I would not like to spend much time typing it out. So I'm just going to explain everything. So how we import assets in Kaboom. So the way assets are imported in Kaboom depends on the assets, of course. We have the way to load fonts is by using the load font method provided by Kaboom, and that's why I like this pattern of having Kaboom as being non-global, is because you can immediately see that if the method is prefixed by K, that means it comes from Kaboom. So the way you load a font in Kaboom is by using the load function method here, and then you pass in the name you want to use to refer to in your code for this specific font, and then the second one would be the path to that font. So this is how you load a font. There's also load bitmap font. I think it's another one where your font is an image and then you specify each character the value, but this is not relevant to this tutorial. To load sprites, or sprite sheet, etc., you use the load sprite method, and it's basically the same thing. If it's a single image you want, so let's say you have only one frame in a .png file, you would only need to first specify a name for your sprite that you want to refer to, and then pass in the path, and that's it. You would close the parenthesis. However, in this case, we have a sprite sheet. That means that we have multiple frames located in the same image. And to tell Kaboom how to slice it, we have to pass in a third param, which is an object that is going to contain all of this information, with also the animations we're going to define. So let's have a look at the sprite. So here we have the player sprite, a sprite sheet, which is located under the sprites folder and under u.png. And here we have a bunch of frames, and I realized one thing is that it's not going to be very visible, unfortunately, because the colors, you know. Okay, maybe I should open Asprite. So this is Asprite, which is Asprite, which is the software I use to draw pixel art. So here we can better see the sprite sheet. So the way Kaboom slice sprite sheets is, first of all, you need to specify the slice x value property and the slice y property. So slice x is basically the amount of frames per row. So in our sprite sheet here, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 slots per row. So that's how we determine the slice x value to be 8 by 9 slots per column, because this is how 1, 2, 3, 4, 5, 6, 7, 8, and 9. As you see, there's a lot of animations here. We're not going to use all of them. So here it's slice 9. Now, for defining animations, you specify the anims property, and then you pass in an object, and each of these entries are going to be the various animations. So for the idle animation, so those names here are names that I have arbitrarily. So those names are names that I have arbitrarily chosen for myself. So you can decide to name them however you'd like. So here I decided to name it the idle animation. And by the way, it doesn't have to be a property like that. It could be a string with I don't know, maybe idle dash player. You could have decided to name it this way, but we're not going to do this here. So here, idle, and then you pass in another object, and this object needs to have the from key, the to key, and the loop, whatever or not you want to loop. And this is optional, but the two main things is these two. You need to basically specify that. However, you can specify an animation as being a single frame. So for example, I don't know, idle 1, I guess, and then I would just specify frame 0 like that. You can do that when you need to just have one frame. So here, from 0 to 7, what does that mean? So this animation that we define as idle is going to start at frame 0. So the way frames are counted in Kaboom, once you have specified slice x and slice y properties, is as follow. So you have 0. You start at the bottom, the top corner, 0, 1, 2, 3, 4, 5, 6, 7. And by the way, you don't count the frame, you count the slots, because even this empty frame is considered frame. So you would have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So here for the idle animation, it's basically 0, 0, 1, 2, 3, 4, 5, 6, and 7. So the first row would be the animation. So from 0 to 7. And here I specified the animation to be looping. That means it will always play. When you start playing it, it will not stop playing until you stop it manually. Certain animations like running, jumping, falling, and idle itself are good to be, we want them to be infinite like that, and we decide when to cancel them. But as for explode or attack, when an enemy explodes, etc., it's just a one and done animation. And for the attack animation, also it's a one and done. We want the attack animation to run and then to stop. When the attack animation is done, the attack is done. And here you also see that you have other optional properties like the speed property, which you can specify the frame rate. Here 16 was a good was a value I thought made the game look good. So that's basically it. You have also another one called the load sprite atlas. So the difference between a load sprite atlas and a normal load sprite is the following. So with a load sprite atlas, you're loading, you're basically cutting out a specific portion of an image. So for the UI, you have this whole thing, and I only need this part. But instead of just like cutting it off, what you can do is just use a load sprite atlas in your code. You specify the file you want to load, and then here you can cut out a specific sprite from it. So here I decided to have a sprite called health bar. It's going to start from within the image at coordinate x 16 and y 16. So you take your image, the coordinate 0 0 at the, is at the bottom, at the top corner, top left corner, and as you move here 16, and then you drop down 16 here, and from this part, from this point onward, you're gonna cut the image with a width of 60 and a height of 40. So this is going to cut the image like that and only keep this portion. And then after having done this, I'm going to also specify slice y as being true, 3. That means I just want to cut out the, basically set this as a sprite sheet. So first of all, I cut out from the rest of the image only this portion, and then I set it as a sprite sheet by specifying the slice y value. That means that every frame, so there's only 3 frames in this this portion, and it's going to be the health bar. So the first frame is going to be frame 0, frame 1, and frame 2. So this is how you would do it. If you had for example, this part, if you wanted to cut out this part, you would specify different x and y values, and then from there different width and height value to just keep this part. And then here it would be slice x3 because there's 3 slots per row, and by 3 slice y will be 3 by 3, so 3 by 3. Hope that was clear. And that's basically it. So here for the sounds, it used the load sound function method, and then you specify the name and then the sound. As easy as it gets. So copy this from the source code on GitHub. I think it would be better that way than me typing it out. So assuming you have this done, our assets are all loaded. So yeah, I might come back here to tweak certain animation, but I shouldn't have to do that because this is taken from the final project. So if we go back to our browser tab, we still have our canvas, nothing changed, and that's pretty normal. All right, now let's, wondering what we should do next is continue creating our folder structure. So I'm gonna collapse this, collapse this, collapse this, and then here in our source folder, I'm gonna create an entities folder. This is for the player, the drones, the boss. I'm gonna put the logic there for them. I'm also going to create a scenes folder, which is going to be the various scenes. We only have 2 scenes here. We have the room 1, which is the big map here, and then we have the room 2, which is going to be just a smaller one. So you can see that if you were to expand this project, you would have a multiple images like the multiple rooms like this that would comprise the whole world. So after the scenes folder is created, I'm going to also create a state component, folder. This is where we're gonna hold the global state. Yep. So I think, and finally, sorry, I forgot. We need the UI folder for the UI. So now we have a neatly organized folder structure. So let's start with the scenes. I think this is the most important part. So let's define our first scene. So our scene, I'm gonna use the concept of rooms, even though this is much bigger than a room, but I started with this. Initially, I didn't think Kaboom could handle bigger maps, so I thought that I would just have multiple rooms stitched together, but in the end it was able to, so that's great. So that's why the name stuck, because it felt too much of a hassle to just change everything now. So let's create a file called room1.js. And in this file, I'm going to have to export a function, async. It's going to be async. I'm going to explain why later on. That's probably because we are going to have to import the map. Actually, I don't think we're going to need this in here. So you know what? Instead of writing async and not knowing why, I will just write a normal function, and then when a time comes and we see that we need it. I'm just gonna add it back. So why I'm doing this? So for now, let's create an empty function called room1, and it's going to contain all the logic defining our scene, this scene. So yep, and I'm gonna leave it empty for now. Let's create another file in the scenes folder. I'm gonna call it room2.js, and it's going to be again the same pattern: export export function room2, and it's going to be empty. Not page transition. Sorry. I messed up. So export function room2. Come on. I'm struggling with my own keyboard. And I made a typo as well. All right. So another function here. And also, like with room1, it's going to contain all the logic we need for our scene. And then in main.js, I think it was in main.js. Yeah. So in main.js, we're going to define our scenes. So here, I'm going to create a function. I'm going to call it main. Actually, you know what? Let's do it directly. So to define a scene in Kaboom.js, use the scene method. And the scene method takes a name, which is going to be the name you want to use for your scene, to refer to that scene. It's a key, basically. It can be anything you want, as long as it's a string. And then the second param is a function, an arrow function, but just a function. And this function is going to run when the scene is called. So here, for now, I'm just going to import room1 from that file and just call it. For now, there's nothing that will happen from this. Optionally, you could have decided to just pass in room1 without the arrow function and just the name. And because room1 is a function definition, it's going to call that function definition. But the reason I'm using an arrow here, an arrow function, is because we want to have like the previous data of the scene at one point, which is Kaboom is going to pass it to this function, and later on it's going to be clear. So for now, I'm just going to leave it empty. So I'm going to define another scene. I'm going to call it room2, and I'm going to have an arrow function as well, and room2. I should import it. Yep. So bubble. Your editor should here we go. I have room2, and I'm gonna call it. Okay, that's for now. And let's have the intro scene, which is the scene you saw that just tells you the control. I know it's a bit lazy to have a scene like that, but because this is for a tutorial, I didn't felt like having a whole menu and yeah, all that stuff. So I just stitched together a simple intro scene that just tells you the controls. All right, and then finally we're gonna use the go method, which basically tells Kaboom to go to a scene. This is important. When you define scenes, you need to use that go function. Otherwise, actually, you don't have to. I don't think you have to. You could have the default code. For example, you could start writing your logic here, and it's going to display. But usually, the pattern is that you define your scenes, and then you call the default one, couple one. Otherwise, you're gonna not know why your scene is not displaying if you don't call it within the main.js file. All right, so we have this here, and I think we're ready to see if anything changed in our project. I don't think anything changed, but you see the loading bar. That means that the assets are indeed being loaded. The loading bar, sorry. All right, so now let's go back to room1, and here for room1, I'm gonna first have our first param, which is going to be a k. Instead of having to import k from the Kaboom loader, oftentimes I will just, pass this k around here. That way I don't have to write this import statement. But I think both approach could work. You could decide to import every time you need K, you just import it from this file. But for some reason, I find myself doing this, and I think it's more convenient, I guess. You don't have to import anything extra. All right, so I'm gonna import the context here, and just to test things out, let's create our first game object. So if you're not familiar with what game objects are in Kaboom, well, it's time to explain this. So Kaboom allows you to create game objects. Think of game objects as entities for your game. They can be platforms, they can be players, enemies, drones, etc. But most importantly than not is that a game object is an array of components. It's made of an array of components. Those components are mostly all, but you can make your custom components, are offered by Kaboom. And this is what one of the driving strengths of Kaboom is, that it makes creating game objects very easy, and it speeds up your game because there's a ton of functionality that you get for free. So that's why Kaboom.js, I think, could be like literally called a game engine rather than a library, because it offers that much. So to create a game object in Kaboom, you can use two functions, two methods. You can either use the add method, or you could use the make method. The make method creates the game object but does not add it to the scene, so it won't be visible, while the add method creates the game object and then display it on the scene as well. So here, for just testing, we want to add to the scene, so to the canvas, and we're going to use the add method. The add method takes one param, which is an array of components. So components, so for example, you can have the text component. This is offered by Kaboom. You can just pass in some text, hello world, and then you pass a second component, which is the positional component. This is also offered by Kaboom, and it's where you want to put this on the canvas. Let's put it at 100 by 100 just to test things out. So here we have our first game object, which is a basically text-based game object. So if I go to see the result, and it's not going to display because we wrote this code in the room scene, but we first went to the intro scene. So let's change this temporarily to room 1. So we go immediately to the room 1 scene. So here you can see hello world in the default font. Now, because we already imported the font in here, we can just use glyph mess here. So something specific to the text components that can take a second param, which is where you define the font with the font property. Glyph mess, oops. And there's a bunch of other properties like the size, the text wrapping, etc. But for now, let's use one property. So now if I go here, you can see hello world written in the font we're going to use for the game. So this is how we create a game object. So, but this is not what we actually want to do for this project. What we want is the actual to actually display the room level. So this is what we're going to do in the next portion of this tutorial. We're going to write the logic to display the maps. I'm going to spend some time hopefully explaining how tiled work and how all these layers, etc., how to make sense of all of this. I also recommend just also reading the blog post I wrote, which is a stripped down, very simplified version of this, just to explain how tiled work. And I think it does a better job than I could do right now. But I'm gonna try to explain those also. Okay, so now we're gonna write the logic to load the map. And the way you load the map, well, before that, let's first color the background. So the background color, I usually don't do that in tiled. So if you see the map here in tiled, it's transparent. Here, the uttermost layer. And that's because it's better to just do color the map, color the background in the game itself. So to do that, I'm just going to create a small utility. So for all logic that is going to be common to both room 1 and 2, or just rooms in general, if you decide to expand upon the project, is to create a room utils.js file here. And in that file, I'm going to create a function that I'm going to call export. First, we're going to export that function. I'm going to call it set background color. and it's going to take the context, the Kaboom context, so that we can use Kaboom related functions. And the second param is going to be the hex color code, which is going to be the color that we want to display. So here I'm just going to create use a game object that is going to be a rectangle that is going to take the whole width and height of the screen and color it a certain way. It's better to use that than the set background method from Kaboom, because the set background method from Kaboom is going to color everything, including the rest of the body of the page, which means we won't have the nice looking bars here in the game. By the way, the game is responsive. I mean, 3 sizes, because we activated the letterbox option. In case I forgot to explain this, sorry. But the letterbox is really so that on any screen size, it retain the same aspect ratio. So here, letterbox here. All right. So now that we have this, I'm going to go back here and I'm going to create the rectangle. I'm going to use the rectangular component, which is just rect. Specify a width and a height, and you can get the height of the current canvas and the width of that canvas by using the height and width methods. So you have the width method, width method, and height, so like that. And then I'm going to use the color component, which allows us to color a given game object with a single color, and I'm going to use the color, I think it's an abstract class, but the from hex method, which allows us to color it by specifying a hexadecimal value, which is used usually, it's most used for colors. It's the thing here in Sprite, for example. And the reason we need to do this is because by default the color component takes a 3 params, which is the RGB values and not an hexadecimal value. And now we have this hexadecimal. And then one thing we need to also use is the fixed component. This will make sure that the camera, this game object in particular is not affected by the camera. So that means it will always remain at the same position regardless. And this is what we want for the background. We don't want this rectangle to basically not cover the whole world, because as the player moves and the camera moves, the part that the rectangle covered is not going to be there anymore. It's not going to be covered anymore because the camera has moved on from the position of the rectangle. By default, if you do not specify a positional component, what happens is basically that the game object will be placed at 0, 0 in your canvas. So that's why I haven't specified a positional component here, because it's not really needed. All right, I save this, and I'm gonna call that inside this the room 1 logic. So I'm gonna pass in the k here, the context, and here the hexadecimal value we're gonna use, it's going to be a specific value. I don't have it memorized, but it's this one. Oops, I should have done this properly. So this is the color. So now if I go back to the game, and there's an issue. And the issue is because we forgot to add a .js in room.util, actually in the import. Remember, because we're not using npm, it is required to have the .js here, because if you don't do that, the error we're gonna have, let me just see if I can zoom in, it's going to be blocked because of disallowed MIME type text/html. By specifying a .js extension, it basically tells us, or tells the browser, etc., that this is a JavaScript MIME type, so it will allow it to run. Now we have the background. All right, so we're making progress, and that's great. Okay, so now the next thing we're going to need is to load the data. So I'm going to do this outside of the room logic. So I'm going to have a room data param. And then back in the main.js file we created earlier on, main.js, here is where we're going to need to use async await, and we're going to have to wrap both these two scenes inside of an async function, because we cannot use top level await, and we kind of need that. So I'm going to have an I'm going to define an async function main I'm going to call it this way, main. Maybe a better name, but for now, let's just call it main. And I'm going to take those two scene definitions. I'm going to put it here. And the reason for that is going to be clear very early. We don't really need to put the intro scene here because the reason I'm going to need to use async here is because we want to first load the data from our JSON file that contains the map data from tiled. So let me just write the logic for that, and then after that I'm going to explain how do you actually get the .json file. So I explained earlier, you can find this in the description, but for the actual map, like how you draw it, etc., I'm just going to do the explanation now. So await fetch. So this is similar like to how you do in web development, where you want to request an API, but this time you just request a JSON immediately. So we're going to take this from the maps dot slash maps, and then the name room1.json. So room1.json, and I'm gonna just do this on one line. So usually people, what they do when you see example on how to make a fetch request is they first put this inside of a variable, they call it response, and then they JSONify it later on. But I'm just gonna do this in one fell swoop. So await fetch, and then that means as long as the fetch call is not resolved, we won't move further. And this is what we want, and that's why I'm using async await, because as long as we haven't loaded the data for the room, we don't want to display the room data. So here we have the JSON as well. So here after you have fetched the data, it's going to give you a response, and then you need to actually convert that to the JSON. So if I go to the actual content of room1.json, you can see this is the content we have. For this project, we don't need really to dive into the tile layers. So tile layers are layers where the data is basically the tiles placed. We don't need that because we don't actually need to render those tiles in Kaboom because we can just use the image that we have exported from tiled. But for colliders, you have here how it looks like. So I'm going to dive into this later on. So now that we have this, we have the room data. We're going to do the exact same thing for room 2 data. And then await, and then await again. Oops. And then I'm going to fetch dot maps slash and then room2.json. And then we do this. All right, so we have both of these room data collected. Now for the room 1, I'm going to pass in the room 1 data. So now if I go back to the, there is one issue though, is that we have defined the main function, but we actually have to call it so that it fetches the data. So the reason I'm actually doing all of this inside of a main function, as I explained earlier, I cannot use await outside of a function in JavaScript. I don't think that's possible. So that's what I'm doing. So I'm calling the main, which collects the data for both rooms, and then define the scenes for both rooms, and then we define the scene for the intro, and then we go to the intro. But for now, I have replaced it with the room 1 for now, just to make our development easier. So I go here, and I have an issue. Scene not found, room 1. Okay, that's because it's called before this is resolved. Because it's an async function. Okay, so maybe I'm going to go back to the intro, and then here let's actually take some user input. So the way you take user input, you can use the onKeyPress method in Kaboom, and then here you can specify as the first param the key. So here I'm just going want the player presses enter. I'm just going to let me just do this like that. So when the player presses enter, I'm going to call the go to the room 1 for now. So now if I look back, I have an empty scene because that's normal, because that's the intro scene, there's nothing. By the way, we should probably just, let's do that later on. But for now, let's leave it empty with just this event handler within the scene. So event handlers like these are scoped to the scene. So you have to re-enable them, recall them when you move on to another scene. So that's one thing that you have to keep in mind if you make a, for example, game where you can move in various scenes. So every time you load a new scene, you have to recall those methods. So yeah, you can write a reusable function for that. Okay, so we have a on key press. When the player presses enter, we go to the room 1. So let's try it out. So here, press enter, and then everything is loaded, etc. Everything works. So if I refresh and do that really quickly, does it actually work? All right, oh, yeah, it works. Okay, nice. So let's go back to room 1. Now that we have the data, it's time to print it out. So actually, I'm going to store the room layers first. And I think this is a good time to stop writing code and start explaining where do I get all of these. So I'm going to go back to tiled. So tiled is an editor, like I explained. So let me explain what we have here. So we have our room, which contains various layers. So the layers inspector is on the top right. It's all the layers I have created. You create a layer by clicking on this button and then selecting the type. There are basically two major types that I use are the tile layer and the object layer. Tile layers are for placing tiles. So here down below you have tile, a little tile. So yeah, what I'm going to do is I'm going to explain just how the current room setup in tiled work, but feel free to please reference to the blog post, which gives you a better picture. So here I have the tile sets here defined. So the way you do this is basically when you create a new project, new file, new map, and then you can import the tile. I said this is all covered in the blog post. So here we have multiple layers. So by the way, this is hidden. So tile layers are for placing tiles. For example, I'm going to hide everything and just show you one by one. So the first layer I created was the platform layer, which contains only the platforms, etc. and various things here. Now I should have probably created this inside of a props layer instead, but sometimes mistakes happen. So that's that. And then here I have the second, so those are tiles. You basically select the tile you want and then you draw. Make sure to select, of course, the layer you want to draw, and then you can just start drawing like that. But this, so yeah, the second layer I created was the props layer, which adds various props, and then here you, like I said, you can select multiple ones like that, and you just place them. So this is the advantage of tile layers. This is what they allow you to do. Now I have background 1, which is again small things, and then background 2, which is basically some buildings, etc. Same logic here. Just use this second tile set. You can load more than one tile set. So to add a new tile set, you click on here, and then you browse, and then you click on OK. So that's how you do that. Okay, now we are done with the tile layers, so layers used to draw things, render things out. Now the collider, the second type of layer is the object layer, and those are used for colliders, so the platforms and visible stuff. Basically, it's more efficient to do this than to have every tile have their own colliders. Otherwise, it's going to be more performance intensive. So just drawing the rectangles here by selecting. So when you create an object layer, you have a bunch of tools here above, and if you just select the rectangle, you can trace a collider. So I'm just gonna Control Z here. And one thing I want to also mention is that if you go to view, you can go to snapping and make sure to have snap to grid or no snapping, depending on the situation. So here, for example, is a collider which is very small, and if the snapping is set to grid, it won't allow you to draw a rectangle that is smaller than a tile. So that's why sometimes you need to disable to no snapping, or snap to fine grid, or snap to pixels, etc. So yeah. And one thing is that when you draw a collider, you can have, so if you click on this pink white rectangle thing, I don't know how to explain it. If you click on that, you have to the left side the properties tab, which contains a bunch of properties, and those are the actual important data. The x and y coordinates of where the collider should be placed and the width and the height of it is important, and it's data that is imported export it to JSON, and is going to be imported in our game. And this is how we know this is the data we use to draw those colliders in our game and to make them basically. So by the way, once you have your map, you need to save as, and then you save as to your specific to the folder where you want to use those maps, and then you just write it a .json extension. By default, it will give you the option to save as a .tmx, but just doing it as a JSON is fine. So here, one example of how this properties tab come in handy is that, for example, here, if I click on that, there's a dog outside barking, so sorry if you hear that in the recording. So here, when you click on that, you can give a name or a class to any of your colliders. And this is useful because I want to give a class of pass-through. This is a name I have decided for myself, but it's important to be consistent because you're going to use that name in your code to know how to what logic needs to be applied to this collider. And pass-through here is logic that I'm going to apply so that the player can jump through that platform and land on it, which is important here. And yep, so we have this is the colliders layer. The positions layer is a bunch of pins. You place those pins here, and basically those are X and Y coordinate. They can have a, I think if I select this, they don't have a width and height. They just have an X and Y coordinate, and they are mostly useful to know where to place things. So here, for example, this is I'm going to place a drone. So depending on the situation here, when you have multiple pins that are going to spawn multiple, like the same enemy type, I prefer to just use a class and call it drone. Otherwise, if it's only a unique thing, I can give it a name. So basically, the only thing that changes is in your code how you access those properties. In your code, you can access the name property by just having a .name on the object. I'm going to show you the code for that later. But for the class, you just use a .type property to have access to the class. So this is how it works. For example, I've placed the boss here. There's only one boss, so I used a name instead of a class. And as for the those drones, there's the pins. And for the health pack, also it's a class because it's the same thing repeated over and over again. And that's basically it. Now the cameras is something new to this project that I haven't done in the previous project. Those are colliders that when the player will collide with them, they won't cause a collision or anything like that, but they will change the camera. Most importantly, they usually change the Y position. So something you can do in Tiled is create custom properties. You do that by just having, for example, this one doesn't have custom properties. You just right click, add a property. So here, if I go back to the cameras layer, so I've put this in a different layer. So just to not confuse, I'm going to hide the collider layer. So here, if I have a property, I want a new property, I do add property and give it a name and a type. And here I used the int type. So this is a value. So when the player collides with this camera collider, I'm going to take this property and the value for it, and then set the camera Y position to that value. So this is how I can make sure that the camera shows specific things and slides, etc. So there's a bunch of them here. So for example, we drop here, the camera will move. When you drop here, it's gonna also move or go up, etc. depending on the situation. So here, it's going to go up. Here, it's going to go up. So it mostly just affects the Y positioning. So only the Y position of the camera. So actually, yeah. So if you're not familiar with game development, usually when the Y value is high, that means we're going up the canvas or down. Yeah, I'm confused. Yeah. Actually, the least the value of Y is, the higher on the canvas you are. That's because so the higher the value of Y, the lower you get on the canvas. That's something I've explained in previous tutorials, but that's how it is done in game development, in graphics library, etc. Okay, now what I want to so there's a bunch of colliders here, and yep, and finally we have the exits collider. And I think one thing before that, for the position, the camera collider, actually the colliders itself, there's this specific boss barrier, which is a specific collider. So if I go back to the colliders here, and this one I have specified a unique CampOsX property this time around. This is an arbitrary name, by the way. I forgot to mention, because when you arrive to the boss gate barrier, I want to slide the camera to the x-axis, not necessarily the y-axis, as I used to do with other cameras. And yeah, it's a collider because it's going to be an actual collider, because the barrier is going to be visible as you fight the boss and you cannot move, and that's why I've put it into the colliders layer. And that's basically it. And then finally, so we have position, I've explained this, and then the exits layer, which is another tile object layer, and this is just to know where to spawn the player in the room 2. So I've named it exit 1, and I've named it exit 2. And yep, so when you hit, the player's gonna hit that, I'm gonna know that the name of the exit, and I'm just gonna spawn you either in entrance 2, or actually this is the spawn point here, entrance 2 spawn point, or entrance 1. So that's how I link those scenes together. And here again, it's basically the same layers. So feel free to explore, open those up in tiled, because they were just JSON file. You can just open them up and play with them. So I'm not going to spend more time on that, but I'm just going to explain one thing though. So to do the exporting as a single image, what you do is you hide every object layer. Object layer, because you just want the graphics. So, and you go to export as image, and then once you click on export that image, you have the path to it, and then you must check this to only include visible layers and keep all the other things unchecked, and then you export. And it's going to give you the room1 or room2.png, depending on which one you export, here and there. So that's an overview of how to use tile. So like I said, the blog post goes into more details on how to do this from scratch. So give it a read. All right, so now let's look at the export to the JSON. So the .json that it was saved. So you don't have to click export, you just have to save your map as a .json, and you can immediately access the various properties. So if I go to room1.json, maybe room2 is going to be easier to parse because it's smaller. So if you were to use a tile, so every tile layer has the data prop. So first of all, let's collapse everything and let's go at it one step at a time. The most important part here, the most important property, is the layers property. The layers property contains all of our layers, and here it is. I'm just going to collapse everything. So each object here is a layer, and let me just collapse. So we have 1, 2, 3, 4, 5, 6, 7, 8 layers, and this corresponds to what we had in tiled, which is 1, 2, 3, 4, 5, 6, 7, 8 layers. But it's reversed. So the first layer here in the array is going to be the lowest layer, because the way usually graphics library works is that the first thing drawn is the thing drawn at the lowest level, the lowest layer. So if you have a tile layer and not an object layer, what you will have is the data property. So this data property specify for each tile which tile in the sprite sheet to draw. If it's 0, it's going to be 0. So it's going to be the absence of the tile, so nothing. And here the number, it corresponds to the frame in the sprite sheet. But because we aren't drawing the tiles in Kaboom, but rather just using a .png that contains everything, because somehow it's more performant, and I don't know exactly how Kaboom implements this and why it's the case, we don't need to parse this layer at all. So any tile layer we have here, we can just safely ignore it. So we're gonna ignore that. And yep, so the way I'm gonna do this in the code later on is I'm just gonna check the type here. So you have this property called type that is either tile layer or object layer. So if we see that we have a type of a tile layer, we can just continue in the for loop. So we're gonna write some code to iterate through that. So the second layer also is a tile layer, the third one, the fourth one, the fifth one is where things get interesting. We are now having a object group. So the object layer is named in the actual JSON file as object group, and The difference is that it does not have a data property like with the tile layer. It has instead an objects property, and it's an array that will contain every object. So here, every collider with the width, the height, and the x and y coordinates. However, if it's a pin, it's just going to contain the x and y coordinates. So mostly for the positions layer, it's going to be that. And using this information, this data, we're going to be able to draw the hitboxes and place the players, the positions, etc. So here I'm gonna put in a constant the layers of our room data, and by just using the layers property, accessing that, we don't need the rest. And then here I'm gonna create a game object that is going to act as the parent of everything. It's going to be the map game object for the scene. And the way I'm going to do this is by having the add function and placing this at positional 0, 0. You do not need to do that, I think, because by default, if you don't specify, it's going to put it at 0, 0. But just, if in case you want to move the map elsewhere, like the whole map, you're just going to modify this value anyway. So I'm gonna set it to 0, 0 explicitly, but feel free to not do that. I don't think it's gonna cause an issue. And here we're gonna load the room, the image, the room 1. So if you remember, when I told you to copy and paste the code from GitHub, we loaded the images for the room 1 and room 2 PNG here, and using the room 1 and room 2 keys here. And then if I go back to room1.js, we can just use the sprite that you have already loaded by using the sprite component in Kaboom. So this will work also for all the other things that need sprites, and specify this as the sprite name. So here we have an object that is going to act as the parent of all game objects. So in Kaboom.js, you can create game objects that are going to act as children of other game objects. So you have here, for now, this game object, the map, doesn't have any parent. The reason we're doing this, by the way, is because the positions are relative to where the map starts in the tiled export, so in the JSON file. So if you were to just create the game object separately, you would have the positions of everything being off. That's why I prefer to just use a map, a parent game object, which is represents the whole map, and then put everything relative to that, as a child of that game object. Okay, so now we can just continue. So then the next thing is to create the colliders, to store in the constant the colliders, which is just going to be room layers and then the actual number. So instead of like, I'm just gonna pick the specific layer that corresponds to objects, and I'm just gonna have the dot object. So here, if we go back to the export, I guess room 2, this is going to be index 4. So if I just collapse everything here, so 0, 1, 2, 3, and 4. 0 because we're in an array. So the fourth element is going to actually contain the objects for the colliders. So the objects property is basically all the colliders data. So that's why I use this. Maybe you shouldn't do this if you want more flexibility, but for this project I don't think it's needed. I have decided to have 8 layers, but maybe if you decide to add more or less layers, or replace them, maybe you want a more flexible system where you're just gonna check, you're gonna iterate through the layers and then check if the name correspond to colliders, and then use that. So actually I could spend the time writing this logic like that, so maybe we should do that actually. Yeah, so if I were to do const for layer of room layers, and then here I'm going to have instead a colliders. I don't like that. I really don't like that. So I'm gonna do this because in JavaScript an array, even if you put it even if you put this as a const, you can modify the content of the array. It's not actually constant. So If I do let here, but I'm gonna assume you know JavaScript. So here I'm going to have if the layer dot name is colliders, then I'm going to do colliders, and I'm gonna use the I'm gonna push to it the room, the layer itself, layer dot objects. So I'm gonna spread it over and then push it all at once. I think it's not gonna do what I think it's going to do, right? Okay, let me just if I put the spread operator, it's just going to create an array within the array. No, actually, actually it should spread it. But anyway, I'm just gonna console.log the result. I don't think this will work, but yeah. So this is something I think is a better coding practice. Layer.object. I forgot typo here. It's objects. So if I go here. Okay, we have an array with all the elements, and that's great. So it works. Okay, it works. So here, as soon as we do this, we're just gonna break. And then if I making sure the code it actually works. Yep, it works. All right, nice. So this is a better way. That means regardless of how you structure your tiled, as long as you have the names right, you can find the layer. It's more computationally expensive to do that because you have to do a for loop and iterate through the layers. Actually, the name of the layers, not necessarily every element in the layer, but I think it's worth it. So here we go. And we break here because we don't need to do any more calculations as we go. Okay, so we have that. And then now what we're gonna do is actually we're gonna write some utils. So in the readme.utils, we're gonna write in a reusable function the logic to place the colliders in the map. So I'm gonna call it set map colliders. And in that, I'm going to need a constant, of course. I'm going to need the map parent game object, and I'm going to need the colliders themselves to know where to place them. And yep, so here, and then okay, so we have everything, and then here we have the collider. So for const collider of colliders, and then so we iterate through them. So here we're going to have, actually, there's one thing I forgot to mention, is that in our collider layer, there's a specific kind of collider that is different from the rest. It's the slope here. It's not a normal rectangle that has been drawn with this, and you won't find this in the blog post because I haven't mentioned it. Here we need to have a polygon. So if I draw a polygon, maybe I should, so I need to select colliders. So a polygon allows us to, have slopes like that. For example, I have a triangle here. The difference is the following. So if I select that polygon, we have an X and Y, but wait a minute, there's something missing. It should, does it actually do anything? So X, Y, rotation, template. There is another property. For some reason, it's not appearing. So basically, what I want to say is that for polygons, it gives you coordinates. There is going to be a coordinates prop. For some reason, this is not appearing here in this part. Okay, parallax offset. Okay, that's strange, but okay, so I'm just gonna delete that. So if I go to the, oh, maybe that was why. So I'm gonna redraw it here, a triangle. And then what happens if I do this? Okay, so it doesn't seem to appear on its own in the inspector here. But if we go to the tile export and look for the slope, this is not going to be in room2.json. It's going to only be in room1. So if I go to room1.json, and I'm going to do a quick search here with Control F and try to find the polygon property. You see? Okay, so it's a polygon property that gives you an object, an array of the coordinates of each of the point of that polygon. This is a specific thing for those colliders that you draw using the polygon tool. So the polygon tool is this one here. So that means in our room utils, we're going to have to first iterate through all the colliders. But now if the collider has the polygon property, then we're going to first create a coordinate array. And then I'm going to have a for loop, and I'm going to iterate through each of the points of the collider.polygon. So collider.polygon, which is the property that contains an array of each of the coordinates for each of the points of that polygon. And then I'm going to push inside my coordinates array those coordinates, but this time around I want to use a vector too. So in Kaboom.js, the way you specify positional components is by, if I remember correctly, here I set to 0, 0, but another option is to pass in a vector 2. So you could have done vector 2 and then 0, 0. So the reason this using vector 2 is useful is that when you want to set the position after the fact, so if you want to do this map and then set the position, it's often handier to just do that. You cannot do other than that, or have to do map.pos.x and then a specific value, and then map.pos.y and then a specific value. So that's a way to make things easier for us later on. So that's why I push them into this coordinates array, and then I just collect point1.x, point1.y. So here we go. And then here, I'm going to add them to the map. So the way you add child game objects to the main game, to a game object, is you take the game object and then you use the add function, the add method on it. So earlier on, we used the add function in Kaboom to create a game object. But each game object has the add method available to them to add child game objects to them. So not only this add method creates a new game object, but it appends it as a child of that map, that parent game object. Sorry. So here, specify the position, and then here I can just do. Okay, that was a bit. So in the original source code, I just did collider x, collider y, which basically defeats the purpose of having created a vector 2. So I'm just gonna use coordinate. Wait a minute. Okay, what's the point of it? Okay, maybe I have created this for nothing. Okay, no, never mind. This is different because we have the position of the collider, which is defined in the collider properties x and y, but now we also need to have the area component, and so there's two things to explain here. Sorry. The first thing, what is the area component? So the area component in Kaboom.js creates a hitbox for your game object. By default, it takes the shape of your sprite component or the rectangle component, the rect component, or any shape you have already specified earlier. But if you don't have a shape specified, you can specify custom shape by using the shape property passed inside of it. And here I'm going to create a new polygon, which is a class constructor in Kaboom.js that allows you to create a polygon based on the coordinates, an array of coordinates. And this is where the coordinate constant we have here is useful, because we can just pass it as directly here. And actually, this is why here it was important to convert this to a vector 2, because this constructor takes an array of vector 2. That's why we had to do it as well. It's not just because it's handy as well. So Yep, we have this. And another thing I'm going to use, and this is to increase the performance, is I'm going to have set the collision ignore property, which is something that Kaboom offers as well, where you pass in an array of tags. So each game object can have a tag. A tag is basically a way to identify this game object. So the way you define tags is in your arrays of component. When you are creating the game object, you can just pass in a string as well, and this is going to act as the tag. And you can have more than one tag. So here I'm going to pass the tag collider. It's just a name I have decided to identify all game objects that are created this way. And in the collision ignore property in the area component, I can pass in that name collider, and it will make sure to ignore any collisions, calculations, etc. When two collider game objects collide with each other. And this is useful for performance because we don't really want to calculate the collision between this and this or this and this. It's kind of useless. So, and it's going to be more performance intensive for no reason. So that's a trick to have more performance. And then finally, we have the collider type. Here it's important to pass the collider type because if you remember, not every collider has a type in our map here, but those oops, I didn't want to create a new polygon, so I'm just gonna Control Z. So if I select it with the pink tool here, if you select this, the class here pass through is going to be referenced. You can access this name through the type property. I don't understand why they're different. Maybe the class property is a reserved keyword in JavaScript. I don't remember. I don't know why exactly they decided to have different names, but this is useful because now we can have create a new tag, which basically is a string, specific for the pass-through platforms by just passing the type here. So if a collider doesn't have a type, it's just going to be an empty string, and an empty string is just basically not a tag, not considered a tag in Kaboom. So that's hope I was clear here. Feel free to ask questions, by the way, in the comments section if you have any issues. And then we continue. So the reason we continue here is because if it's not a polygon collider, we need to write different logic. So here, the next case is that if we have a collider and the name of the collider is a boss barrier, which is one of the exceptions here, what we're going to do is, oops, here we go. So if the collider name is a quote boss barrier, we're going to create the boss barrier, but this time around, we're going to store the reference to that game object. It's still going to be a parent, a child of the map game object. So one thing is handy with the add function and the make function as well, you're going to see later on, is that it gives you a reference. It returns a reference to that game object when you use that. So you can keep it here, keep it handy here. So here the boss barrier, I think I'm going to, actually, you know what? For now, let's skip that. I'm going to do to do, and we're going to do that later on. And if we're going to continue to the next iteration. And then the last case, yeah, so all the other cases are just normal colliders, and we can just add them as a child of the map and specify collider X, collider Y. But for all those normal colliders, the shape we're going to define is just going to be a normal rectangle. You can specify this by using the rect constructor here. It's different. It's different than the rect component. The rect component actually draws the rectangle, while the shape, creating a rectangular shape, is just going to make the hitbox. All hitboxes like this can be viewed if you press the F1 key and enter debug mode. Well, actually, you enter debug mode by pressing the F1 key. So if I do this, so here for the rectangle constructor, the way you create a rectangle, you have to pass 3 params. The first one is the position, and I'm just going to pass an empty vector 2. This basically tells that there is no difference from, because if you were to specify values here, X and Y coordinates, it's going to draw the shape, the hitbox relative to the game object. And in certain cases, you want that. You want the hitbox to not be directly aligned on the same position as the game object, but sometimes you don't want that, so you just specify a 0, 0 vector 2 here as the first param. And then the second param is the collider width, and the collider height here. So here we go, and here we're gonna use the body component. So the body component is a component that can only be used when you have the area component defined. So you first need to have the area component defined because you need the head box, and the body components for physics. So here we want to have the physics of, so by default, if you just call k.body, if you just add the body component, it's going to make your game object susceptible to gravity. If you specify, though, inside of it the isStatic property and set it to true, it's going to be a wall, basically a static body. It won't move when collided with. It's going to act basically as a wall, an obstacle. And here I'm going to also have the collider tag, and I forgot to add the collision ignore as well. Collision ignore. Oops. Collider. So I've explained this already. So, and we also pass the collider type. As I said, for the pass-through platforms, this is going to be useful because for some of them, it's going to... Actually, you know what? Since we have only one slope, if we go back to the polygon, we actually don't need to pass this type here. Because in case you want to in the future to maybe have passed through platforms that are also slopes like that, I guess we can just let it be. So yep. Yep, we have done this, and now it's time to call that function in room1.js. So in room1, yeah, here we have the colliders. So right below, I'm gonna call it set map colliders. It's gonna import it from roomutils.js. Make sure that this is a .js, and here, okay, and then pass in the map. So k for the context, and then the colliders. We can just pass the colliders. Colliders. Here we go. Let's test everything out. So if I go to the browser, hit enter, you can see the map being fully drawn, and the colliders also by pressing the F1 key. Now, for now, the performance isn't very good, but you're gonna see later on we're gonna do a bunch of stuff. I think we're gonna add a few things that makes it, I think the off-screen component. Actually, I think the performance is good. It's just my PC, where when it's unplugged, it runs at a lower frame rate. Yeah, and also the fact that when you open up the debug mode, it adds a bunch of drawing calls to draw the layers, and that's why the FPS count drops. But the actual game performance as you're playing, it should be 60 FPS. So now, because this is not very inviting to look at because it's too small, I'm going to do a bunch of camera operations. So in Kaboom.js, you can control the camera relatively easily. So here, I'm just going to call the cam scale method. Allows us to zoom the camera. I'm going to zoom it four times. I think this is what will look good. For the cam position, I'm going to put the default position at 170 by 100. Those are all arbitrary values. I just came up with them by experimenting. And then I'm going to set the gravity to being a value of 1000. I don't know what the metric is, the unit for that is, but 1000 is what felt good. But for now, it shouldn't have any impact because we don't have any kinematic body or any player or enemies yet. So if I go here, press enter, you can see the map. So in the next part of the tutorial, we're going to hopefully start working on the player and the logic for that and making the player move, etc. All right, now that we have the map here displayed, we could proceed on and work on the rest of the map, cameras, etc. Or we could start and work on the player. So I think we should actually go and work on the player logic. I think that would be the best, so we can start implementing movement, etc. And since we have the map, it's going to be easy to test things out. So now what I'm going to do is I'm going to go to the folder structure and then create in the entities folder a new file. This file is going to be called the player.js and it's going to contain all the logic we need for the player. So here we go. So here, what do we need? So I'm just going to collapse this. So what do we need is, first of all, I'm going to create a function. And this function, I'm going to call it make player. So in Kaboom.js, usually there's nothing against object-oriented programming, but usually don't use classes. Well, I usually don't use classes, and if you look at the examples on the docs, etc., usually don't use classes. So here the make player is going to act as our constructor, but yep. So it's going to we're going to use the make function this time around, the make method. So yep, the make method is like the add method in Kaboom, but instead of creating a game object and then displaying it on the screen, what it does, it only creates the game object. So later on, you can take the game object and then put it inside of an add call to really add it to the scene. So here I prefer to use this make function to actually make the game object, and then in the room logic, in the actual scene, I'm gonna make the call to actually put it as a child of the map. So here we go. So here, what are the components we're going to need to make our player? So just to circle back on the reason object-oriented might not be really used, but you can actually use it. But the reason is that when making a game object, you can pass in an array of components. You can pass a string that will act as a tag, but you can also pass an object. And this object can contain basically your methods for your game object, so you don't need to create a class. So for example, here, let's first add our game object, our components that we're going to need for this player character, and then as we go on, I'm going to add a bunch of methods for the actual behavior, etc. we're going to need inside of that object. So first of all, the positional component is very important. Now, one thing I forgot to mention is that you need to call this, you need to actually use the positional component, even though by default it's going to just put the player at the position 0, 0. And that's because if you want to modify the position afterwards, it's important to have the positional component used here. Otherwise, it's not going to work. Now, I'm not really sure about that, but I think I remembered it that way. So maybe try it out and see if you can do without. So now I'm going to also use the sprite component. And I'm going to here use the player sprite. This was defined earlier on in the Kaboom loader. So if I go here, Kaboom loader, and to the first load sprite call here was where we loaded our player. So here, yeah, we just load the sprite, and then later on we're going to pick an animation and play them. Okay, what do we need else is the hitbox. So as I mentioned earlier on, hitboxes can be created by using the area component. By default, if you just don't do anything except just using the area component, just calling it, you're going to have a default hitbox that takes roughly the size of the sprite. But I want more granular control over that. The reason I want more control is because I want to actually the hitbox to be the constant and the same regardless of the various animations, and I want to place the hitbox in such a way that the player is going to look good in terms of movement, etc. So the frames should be well positioned. So here I'm going to use the shape property that I've shown earlier on, and again call the new and then k, and here of course I forgot to pass in the k, the Kaboom context here. So I'm going to use the React constructor as I explained. Here for the first param, we're actually going to offset the hitbox to be at 0, 18. So this 18 y coordinate relative to the actual position of the game object. And here I forgot a comma, so maybe here I should probably have this to have it well formatted. So shape new k.rect, and then as the first param here. Now this is a value I've played with. Later on when we're going to actually look at the results, you're going to see that like what looks good. The second param is going to be the width, and here it's going to be a width of 12, and the height is also going to be of 12. This way, the actual sprites I think are 16 or 32 by 32. The reason I'm using 12 by 12 here is because it's the hitbox is going to be small enough so that there are still some collisions. The player cannot move in weird places, but it's also small enough so that the player doesn't get hit all the time. So it's a generous, I guess, hitbox to be small. Okay, now I think that's it for this one, and we can move on to the next one. The next component, sorry. So the next component we're going to use is the body, the anchor component. So the anchor component, it's a new component that I haven't explained yet. This allows you to center, to determine from where the sprite, the game object is drawn or centered. By default, all game objects are placed or centered from the top left, from their top left corner. If we don't want that, we want actually the center of the game object to be the position, we can use the anchor component to specify that. You can specify center, top left, top right, and you can even pass, I think, a vector 2 as well if you want more control. I'm not sure about that last one, but I think in the platformer tutorial, the one, my 8-hour, 7-hour, almost 8-hour tutorial, I think I did something where I control actually set the anchor to be a specific value. I'm not sure though. I don't remember that project that much. Anyway, once we have this, I'm gonna also use the body component. This is very important because since this Metroidvania is a 2D side scroller, it's basically a platformer, so we need to use the body component so that the player is going to be affected by gravity. That means that it's going to be like it's going to fall, etc. And here we can specify a bunch of other properties. So we can specify the mass of our player. I'm going to use 100 as the value. How I came up with this was just by tweaking. And we can also set the jump force. So this is when we're going to implement jumping. You can set up in Kaboom.js the jump force. And here 320 was a value which I thought was powerful enough so that the player can have a nice jump, but not too much so that they hit the ceiling of the levels. So here we go. And we are also going to add the double jump component. So double jump is a component that is provided by Kaboom that allows you to easily implement multiple jumps. It doesn't have to be double, so you could have more than that. Now here for double jump, it's I usually set it to 1 initially, so I'm gonna set it to 1, and then as we unlock we beat the boss, it's going to be set to 2. But the logic for this isn't here yet, and actually, you know what? It's a good time, I think, to start handling our state, setting the groundwork for that. So we want to have global state to keep track of our player's progress, and I'm just going to create that in a folder called state. I'm going to call the file global state manager.js. And the pattern I'm going to use is going to be very simple. So here, what I'm going to do is simply, I'm going to create 2 things. I'm going to create first a constant that is going to be the state props enum, and you're going to see why in an instant. And the second one is going to be a function, and I'm going to call it init state manager. And what it does, it's going to return, actually first we define a state object, which is going to contain a bunch of state we want to keep track of. For example, the player HP. By default, we want the player HP to be 3. Then the max player HP, we want it to not exceed 3, because for this project specifically, the health bar in the sprite work, the assets, is basically 3. And it's not very flexible. So instead of fighting this, etc., I'm just gonna make sure the player only has 3 lives. If you were to actually expand upon the game, I would recommend just making your own UI components yourself, or maybe tweaking those sprite. For example, you could just take the outer frame of the UI. Here you could take the outer frame, So for example, you would cut out all of this pixel art and have all of this part transparent, and then you would fill it in with color. Actually, I should have done this with a rectangle that grows and shrinks. So yeah, just some ideas you can yeah, try. And then here I'm gonna have it is double jump unlocked, and I'm gonna set it as false. Player is in boss fight. Another, and I'm gonna also set it as false. And then is boss defeated, and then I'm gonna set it as false. So as you make this game grow in complexity, you can have a bunch more events here that you want to listen on, and state you want to keep track of. Now I'm gonna return here. I'm going to return one thing, a current method. So by the way, in JavaScript, you can define functions like this within objects. This is a shorthand for this, which you might be more familiar with. So I prefer to just do that. And here in this current method, we're going to return a copy, a read-only copy of the state. So while the user of so the one who calls the current method can modify the object here, it will not affect the actual state. So for actually setting the state, we want to create a setter. I'm gonna call it set here. It takes in a property as a string and a value you want to change, and then here internally it sets the actual state here for the given property to be the value here. Oops, not value. Here we go. So here we go. And here it's where things could get messy, is that since this is a string, you could pass in whatever you'd like. That's why I created this state props enum, where you can actually, maybe I'm just going to copy and paste this. You just have names like that. Player HP refers to the player HP string. Now, this isn't ideal in terms of, like, if we were working with TypeScript, we wouldn't have to do something like that. But I think it gives us a much nicer way and less error-prone way of setting the state. So just to explain, if here I want to only unlock the double jump for the player who has defeated well, actually, if I want to only enable the double jump if the player has the double jump unlocked, then what I would do here is I would do state, and then did I export it? Sorry, I forgot one. Very important stuff is to have another export where this is just a function that we call, and then we have export const state, and then this is what we're going to actually export. So I'm going to initiate the state manager, and then this is the state that we export. So here in the jump, I'm going to type state, and then import it. Here we go. And then don't forget to add the .js. And then once you do that, you can do state current, which is the method which is going to give us the current state. And then you can immediately just have access to the properties here. So is the double jump unlocked? And if that's the case, we're going to use a ternary here, ternary condition expression, because it's compact. And if it's the case, what we're gonna do is simply set the number of jumps to being 2. Otherwise, by default, the player can only jump once. So double jump is a component offered by Kaboom.js. It allows us to really build this feature out very quickly, and that's great. Another component we're going to need is the opacity component. This allows us to control the opacity of the game object. This is going to be useful when we want to make the player blink when they get damage. That way, when that happens, we can just control the opacity. Otherwise, you cannot control the opacity. And then I think that's it. The last one is the health component. So Kaboom offers the health component, which allows you to manage health very easily. And here what I'm going to do is initially you initialize the health component with the HP for the player. And this, we're going to pick this up from the state. So for example, if in room 2 the player in room 1 the player takes damage, so in room 2 we want to actually keep track of the player health. That's why we recreate the game object for the player every scene. So when we go from scene 1 to scene 2, the make player function is going to be recalled, and that's why we need actually to keep track of the health. So that's why, otherwise it will reset to the value if we were to hard code it here to 3, even though the player is just exploring another portion of the same world. So state.current and then player HP. All right. And then finally, we'll have a player tag. This is going to be useful when we want to have on collide events. We can just use that tag so that other entities can just check for that. All right, so now that we have this done, it's time to actually fill this object. So one thing, the reason why object-oriented programming in terms of using classes is not that necessary when working with Kaboom.js is because you can specify properties within here. So here I created the speed property. I want my player to move at the speed of 150. I also want to set the is attacking property to being false. So this is a property I created just to keep track of when the player is attacking. For example, when the player is attacking, we want to make them not vulnerable, so they can't take damage when the attack animation is running. Otherwise, it would be I think it was a better way to go about for this project. Okay, so here is our first method. It's going to be set position. Now for this, really, I don't think this method is really necessary. We could just have a position here. We could call it the initial pause. I don't think I ever call this ever again except for placing the player, so I can just do this like that. So I'm not gonna use that. If there's any issues, I hope I will remember to just check here and re-add it. So okay, so the first actual method we're gonna use create for our player is the set controls. Set controls is going to be a method that is I always mistype and press the P key instead of the brackets, which they're near each other, so that's why. And then it auto completes with page transitions. So okay, so this set controls, what it's going to do is basically set the player controls. One thing that's great with this wait a minute, yeah, one thing is great with this creating methods within the object is that you can use this like in a class and create attributes that can be used by other methods. So it's basically just object-oriented programming. So here, this control, I'm going to create a new property, and the way you could do that is just this, and then the name of the new properties you want to create. I'm going to call it control handlers, and it's going to be an array that will contain event listeners, reference to event listeners for the various controls. And the reason I create this is so that I can cancel all of these events, event listeners, when the player dies. Otherwise, the player could die, explode, and then continue to move while the exploding animation is playing. So here is the first call. So I'm gonna create this control handlers. I'm going to push into it our first event listener that I'm going to define within this push call, this push method. I'm going to use the on key press event listener like I've shown you earlier. And this time around, I'm going to use a different form of the key press event handler from Kaboom. Instead of specifying the key here, for example, enter like I did in the main.js file, what I'm going to do is I just pass the arrow function, and as the first param, you can get the key. By the way, this is an arbitrary name. The first param is going to be the key, regardless of what it's named, just for your information. So here, key on key press, the key here. So what I'm going to do, I'm going to have an if statement. And then if the key is for x, let's say we have x, and if from within this dot current animation. So what is this from? So one thing is that this not only gives you access to the properties you created, but gives you access to the whole game object. And usually in Kaboom.js, when you create a game object, it has access to new methods and new methods depending on the components you have used. By default, all game objects that uses the sprite component have access once they're created to the current animation, current anim method. Now this is going to be called when the game object is going to create, so that's why we can actually start using them here. So here, this current anim allows us to know to check what is the current animation. So if the current animation is not the jump animation, then wait a minute. What we want to play, actually, we can use the other method that is available for all game objects that uses the sprite component. It's going to be the play function, allows us to play the play method, sorry, that allows us to play animations. So here I'm going to play the jump animation. All right, so if you remember, the jump animation is what we defined earlier on in the where is it? The Kaboom loader.js. So load sprite player, and here it is. So from frame 51 to 51, so it's basically just one frame. And you know what? Actually, I realized this. You could just have set this up like that, one frame. Instead, if it's one frame, you don't need to have all this. You can just have one like that. All right, so let's do this. So if the player press the X key, we first check if the current animation is the jump animation. If it's not the case, we play the jump animation. That's important because if the player press more than once the X key, we don't want to cancel it, but it doesn't really matter in this case because the animation is one frame. So even if you spam again, it won't matter because the same frame will play. However, this would have been useful if the jump animation has more than one frame. So I'm going to keep it in case you want to modify the jump animation to have more than one frame. And then finally, we just call the double jump component, and this is going to take care of either making the jump for the player. So if the player is allowed to do more than one jump, they're going to be able to do, and it's the double jump component that takes care of that. If you're new to Kaboom, by default you also have the jump component. So this jump component is unlimited, so don't use it if you want to use this double jump mechanic. One thing, if you use the jump animation, the jump method, what you need to do is check if the player is grounded. So there is the isGrounded method on every game object that uses the body component, and by checking you can actually allow then the call for this jump. Just for your information, you can look at previous tutorials. Usually by default you implement the jump mechanic using the jump component, but this is a special case where we actually want to allow more than one jump as part of the ability that the player unlocks after beating a boss. Here you could have decided to have a switch case statement, but since we only have two cases, I'm going to just go with one if statement. So the next key is going to be the Z key. Now, depending on if you're in a European keyboard, the Z and the X key might not be the same in the same place as the QWERTY layout. So in that case, either in Kaboom.js you cannot have the keyboard layout independent keys. You cannot set that on key press. So as a workaround to this, what I would recommend is maybe allow the player to remap the keys in a settings menu. That you can do. All right, so if the Z key is pressed, and here we can also check. So the reason this is in another if statement instead of being on the same one is that we want to allow the double jump if possible, even if the animation was already playing. But for this case, if the Z key is pressed and the current animation is not an attack, current anim is not the attack, only then we will allow the attack to go. Otherwise, yeah, because the attack is already in motion, if not the case. And we also want to check that the the player is grounded. So this is something that is particular. So it might sound strange. Why would the attack only be available on the ground? Well, the reason for that is that the asset pack doesn't have animations for jumping attacks, and I didn't feel like adding an animation. So just for the gameplay not to be weird, the animation not to be weird, I just decided to, you can, this robot, the robot character that we play can only attack when they're grounded. So what happens when an actual attack is fired? So here is the logic. You need to write this logic here. So first of all, we're gonna set the isAttacking property to being true during the attack. We are also going to create a new game object. This time around, this game object is not going to be a parent of the map. The reason for that is that actually thinking about it, it's not necessary. Yeah, I should have probably. Never mind. This game object is going to be a child of the game object, the player, which is a child of the parent. So never mind. We use the add function, the add method to create a new game object. It's going to be the hitbox for the sword attack. So the way we're going to implement this is that when the player attacks, we create an invisible hitbox that is that if the enemy collides with it, then we register an attack and we deal damage to the enemy. So here I'm going to set the position of that game object to be this. First, flip.x. I'm going to explain this line of code in an instant. Let me just write it out. So here we go. So what does this do? Why I'm doing this? So flipx is a property that is available on all game objects that uses the sprite component. What it allows you to do is to flip like a mirror the sprite, and what that means is that instead of having a left-facing sprite and the right-facing sprite, you can just get away with one and then just flip it around. So if the flip animation, so if the sprite is facing left, because by default the sprite is facing right if you look at the images. So if if the flip x attribute or property is true, that means the player is now facing left. That means we need to move the hitbox to be to the left. And that's why I have this ternary operation that does this. It will subtract -25 to the current position of the hitbox, which is by default, since it's a child of the player, its position is going to be relative to the player. So -25 is relative to the player. Otherwise, it's going to be 0 and 10. So 0, 10 is what looked good. So the hitbox is going to be drawn from, remember, the top left corner. Every game object by default is drawn by the top left corner. It's only when you specify with an anchor component, center, etc., that you can center that instead of being drawn from the top left. But for this, the attack hitbox, we don't need that. All right. The second game object is going to be the area component. So the area component is going to have a specific shape. So here again, it's the hitbox. I'm going to use the rectangle. It's the simplest shape. Here we don't need an offset for the position, and we're going to make our sword hitbox 25 by 10. This is what looked good relative to the animation. And then finally, we're going to also have a tag. So the tag is going to be not here, outside here, sword hitbox, which is going to be used to create event listeners that listens on collisions with this particular tag. All right, we have this, and then of course we need to play the attack animation, again defined in the Kaboom loader that we did earlier on. And then here we're going to have a onAnim end, which is a event listener offered, a method offered by Kaboom for every game object that probably used a sprite component. And what it takes is it gives you actually the animation name, and then you can write some logic. If the animation was the attack, then we can first get the sword hitbox. The way you can get a game object by its tag is by using the get function method, function actually. This is a function from Kaboom, and we pass in the tag. And since this sword hitbox is a child of another game object, that means we're going to have to use recursive true, and the get method function gets all game objects with this tag. That means if there's more than one, it's going to get them and return an array. So because it always returns an array, even if there's only one, I'm gonna just pick the first element. There's only anyway going to be one sword hitbox created at a time. So if the sword hitbox, we first get a reference to it because we don't have access to this. Actually, you could have decided to create another property within the here within, but since we destroy that game object, it's better to just use the get function, get the current sword hitbox that exists, and then destroy it. So here we do this, and then if only if the sword hitbox actually exists, because sometimes the sword hitbox might already be destroyed before a new one is created if the player hits the attack key again. So in that time, sword hitbox will be undefined. So that's why we need to guard this with an if statement, otherwise it's going to fail. So here I need to, and then only if the sword hitbox exists, then we can call the destroy function offered by Kaboom to destroy a game object, and we pass the reference to that game object. And that's it. And one thing we want to do is set the is attacking attribute now to being false since the attack is finished, and we want to play the idle animation back. By default, the idle animation always plays all the time when the player isn't doing anything. So even after an attack, we set it back to idle only, and then when the player decides to move or do something else, then we will play other animations. So this is our first control handler, and let's do our second one. Our second one is going to be, again, I'm going to push it to the array in much the same way. This time around, what I'm going to do is do a key on key down instead of on key press, on key down, and yep, on key down, and then again pass the key here. And now here, if the key is either left, no, if the key is left, so if it's the left key is down, and the player is not attacking, this again, it makes no sense gameplay wise. It might be strange, a strange gameplay design decision, but as I said, because I do not have the animations for the left and right attack as you move, and it just looks weird because the player is basically standing still and attacking. So that's why I made sure that you can only attack when you don't press any other keys except the attack button. So if key equal left, and this is attacking, what we're going to do is we're going to have another if statement. If this dot current animation, so this again is the animation guarding logic. So if the current anim is not the run animation, and we also need to make sure that the player is grounded before we play any running animation, because otherwise running while in air is kind of going to look weird. So because of that, we need to use the is grounded. Again, is grounded is a method offered by Kaboom for all the game objects that have the body component. Okay, so we have that, and if that's the case, we can do a this play and then actually play the run animation. So we have all the conditions to play the run animations, but again, this is an if statement within an if statement, because we can conceive of a case where we want the player to still move even though we don't want to reset the run animation because it's already playing. So here we go, and I'm gonna make sure that you need to make sure actually that the flip x value is false, because the way that flip x works is that if you set it to true, your player is going to be mirrored all the time unless you actually set it back to false. And because by default it seems here that the player is actually facing left by default and not right. No, actually that's contrary, it's facing right, so this should be true. We want to always make sure that the flip x value is true, so that the player is flipped when they press the left key. And in the other if statement, where it's going to be the exact same logic but for the right key, we're gonna make sure that the flip x is always true, always is false, set to false, so that the player will return back to their original orientation, I guess. And then finally, for moving the character, we can just call the move function a method. Again, this move method is offered by Kaboom for all game objects that have the body component. And here the move method takes two params. The first one is the speed in the x-axis, and the second one is the speed in the y-axis you want to go for. Because we want to only move left and right, we're only going to do a negative speed value and then 0 for the y coordinate. So here we have the speed here defined here, so we can only need to modify the speed in one place, and negative because we want to go left. So the value of the speed should be negative. All right, we have that, and we can return early. We don't need to go further down, and the rest of the logic is the same thing, but for the right direction. So here's the same thing. We don't actually need the return statement, only if you were to want to have some extra logic here. But I'm going to keep it just for consistency. So here it is, the second one, just copy the code. It's the same logic, just two values. You could maybe have a reusable block here. Yeah, you could have some reusable logic, but it didn't feel worth it. So now that we have this, I'm going to save, and then I'm going to have the last control handler. So this control handlers and then push. This time around is for when the player releases a key. So to do that, we're gonna do on key release, and then we don't need to actually check which key is released. We want to run this logic for any keys that is released. So if this current animation, okay, this is going to be really tedious to write, but it's kind of necessary, so I'm just gonna paste it here and go over it. So this is the logic. So we want to make sure, as long when a key is released, any key, if the player is not idle, if the current animation is not idle, the current animation is not jump, the current animation is not fall, and the current animation is not attack, if any of those animations are not currently playing, then we go back to the idle animation. And I think that's it. Now let's go back to the let's go back to the main.js file. Actually, no, to the room1.js, and let's create our player here, just so we can see something on the screen. So what I'm gonna do, okay, I see why I created this set position. Let's create our method here to set the position it's actually going to be used. So set position x and y value, and then I'll put page transition, and then here. Okay. So this position dot x, we set the x new x position. This position dot y, we set a new position. All right, here we're gonna remove the initial position here as well, not needed, and here we go. All right, in room 1, what we're gonna do is, right after setting the map colliders, I'm going to actually define the player here and add it to the scene, but without specifying a position. So here I'm just gonna call, actually you don't need that, you just call the make player function from within, pass in the key, like that. So when you use the make function, you only need to call the add method on top, and we actually need to add this as part of the map. So now that we have a player created, let's write the logic for the position. So in much the same way here, I'm gonna create another const, I'm gonna call it positions, and it's going to be an empty array. And then here, instead of breaking, I'm going to have a continue, and I will have a second or first if statement that checks the layer name for position, positions. And if that's the case, then we're gonna push to the positions array. Push. Yeah, we're gonna push the layer. We're gonna spread the objects here. So the spread operator, look it up. It allows us to take an array and then spread it back into another array without like having an array in an array. So you take the element of one array and you put that into the second array, rather than putting the first array inside of the second. So it's basically, instead of having this, you'll have this and then every element 1, 2. So imagine 3 and then 1, 2, and 3. So if you were to not use the spread operator, this 3 dot, this is what you would get. But because you use the spread operator, it takes the elements of the first array and puts it inside of the second. Hope this was a clear explanation in case you're not familiar with this syntax. Okay, so positions, push, layer objects, okay. And then we should have all of our objects. So I'm gonna continue here as well. So here for now, this is not necessary. Okay, so now what I'm gonna do is for const position of positions, and then here, if the position, for now, let's do it simple. If the position is of the player, position.name is the players, is how we detect the player pin. So this one, if you remember. Here we go. So here, it's named player, so by checking for the name. So if it's the player name, what we're gonna do is we're gonna have the set position, call to the set position method, and we're gonna take the data from this positional pin and set it as the position for our player. Now we're also going to set the controls by calling the set controls method. And for now, that's it. So if I look at the result, let's see what we get. Press enter, and we have our player. And our player can move. Can it jump? It can jump, but this time, yeah, you see the animations aren't resetting properly because we didn't add yet the handlers, not the handlers, the events. You're gonna see in a moment what I mean by that. So one thing also, if I press F1, you can see the hitbox, how it is positioned, etc. And when I use the sword, you can see how the hitbox change direction. All right, now that we have this, I'm gonna go back to the player, set the events. So the events are things. It's a new feature that I've discovered in Kaboom.js. It's not actually new. It was probably there, but it's new to me. So okay, before doing that, yeah, okay. So set events. This is the method I'm gonna call, and within this, we're gonna set a bunch of events. So onFall is an event offered by Kaboom. It checks for when the player falls after jumping. And this is where we're gonna just play the fall animation when that happens. So the onFall is something offered by Kaboom. This onFall_off, though, is another event offered by Kaboom, but this time around, those events are all specific to the game object, so it's not a global event. onFall_off, the difference is that it's for when the player falls off a platform. That means there was no jumping before that. Here again, we need to play the fall animation. Now we also have this onGround, which is another event offered by Kaboom. And when the player is on the ground, we want to play the idle animation. And then finally, when actually it's not finally, there's a bunch of others, but for now, there's this the onHeadbutt event, which is when the player hits his head on a platform, or when the player hits an obstacle with its head. So for example, when the player jumps and hits the ceiling of a level, then this event will fire, and here we're gonna play the fall animation. So now let's just test this out. So I'm gonna go back to main.js. I'm going to actually room1.js, and here I'm gonna set those up. So player.set events. And now if I go and check the result, hit enter. You see the animations are now perfectly correct. And then if I hit, so this is a, oops, we don't have the camera system working yet, but here is the natural progression. Here we go. If you hit headbutt, immediately the fall animation will play. And that's that. We have a bunch of other controls, and that looks good. Now we want to make sure that the player can pass through these platforms. So we're going to create another method. I'm going to call it, what's the name I'm going to use? It's going to be an enable pass through. So maybe, where should I put it? Okay, let's put it right here. So enable pass through, and here we go. And here, how to do this feature is there's something in Kaboom, a method called the onBeforePhysics resolve. What it does, it gives us the collision that happens as the first parameter here, and then you can check for that collision. So if this collision is a specific target, so if the collision is with pass through, which was the tag you remember we had for those specific platforms where we want them to pass through, that we set up in tiled and then added to when we create the game object in the set colliders method function. And then here we make sure that the player is jumping as well. And this again is a method offered by Kaboom to know when the player is jumping. So, and then if those two conditions are met, so that the collision is supposed to be with a pass-through, is happening with a pass-through, and the player was jumping, we want to prevent the resolution of the collision. That means we don't want the collision to actually take effect. So that's why we call the collision dot prevent resolution. Okay, so once you call that, I think that's it. The feature is implemented. For more details, I have a blog post regarding this, so go to my Substack for that. So if I go here to room 1 and call the player.set pass through method, enable pass through, not set pass through. Actually, enable is a better name, but set would have worked as well. So if I do this, press enter, and then let's try it out. Even though with the camera it doesn't work, you can see I can pass through the platform, and even here as well. But here I cannot jump enough anyway, so here we go. But when you're going to be able to double jump, you should be able to pass through that platform as well. All right, we have everything we need for our basic player movement. There is a bunch of logic when it comes to dealing and taking damage that we're going to write later on. Now, okay, let's do the camera system. So for the camera system, what I'm going to do is we're going to have to go back to our room1.js. And the same thing with what that we did for the colliders and positions, we're also going to need that. But this time around, yeah, we're also going to need to get the colliders for the cameras. The way I did it in my, yeah, that's strange. Okay, it's going to be a bit different. So let's go to room.utils and write a utility for that, because it's going to be used for both the room 1 and room 2. So here I'm going to create an export a function. This I always make this mistake. Function set set camera controls, and then here we're gonna pass in first the player, first the K for accessing all the Kaboom functions, the player, the map, and the actual room data. And then here we're gonna need, first of all, actually, never mind. This is not the, this function is going to be useful, and it's going to be mostly used to control the camera. So I'm not gonna write the body of it right now. What I'm gonna do though is right below, I'm going to write the function for the camera zones. So the camera colliders, I just call them camera zones. And we need to just have 3 params, which is like we did with the colliders. It's basically the same thing. So we're gonna have 3 params. The first one is the Kaboom context, the second one is the map object, and the third one is going to be the camera's name, in much the same way that we did for the colliders. So let's assume that we have all those 3 for this for the time being, and then we will write the logic for that in the room1.js. So we have a for loop, and then we're gonna get the camera of cameras, which is our colliders, our data for those colliders that we had entiled. And then here for the cameras, for each of those camera colliders data we have entiled, we're gonna create a camera zone game object. That game object is going to, of course, be added as a child of the map. And we're going to have basically the same exact way we did for the colliders. So I'm just going to copy and paste the code here and explain over it. So an area component, which is a rectangle with the width and the height, and collision ignore being the colliders. Since the camera really don't ever enter in collision with themselves, we don't need to add a tag for cameras. Okay, so now the reason I created this and stored it in a camera zone constant is to have set our first event listener, which is going to be our camera on collide. So I'm just going to copy and explain here. So on collide is a method available on all game objects that have the area component. So here how it actually works. So you have your first game object, you have its method on collide, and you can pass in a tag as the first param, which is what tag you want, what game object with the following tag you want to listen on. When regarding collisions, in regards to collisions, sorry. And the second param is the function that is going to fire when that event happens. So here, when the player collides with the camera zone, we're going to run this logic. This logic is simple. We get the current camera position by using the campause method function offered by Kaboom, which returns in vector2. That means we can have access to x and y properties for the camera position. So we make sure that if the x position of the camera is not equal to camera properties 0.value. So okay, so what is this? So this is, if I go to the export, okay, so the room1.json, maybe room2. So let's go to room2 because it's smaller and easier to detect or parse because of its smaller nature. So here in not positions, but in we have positions. Okay, in cameras, you see here the custom property that I created called CamPauseY is added to a new properties tab here with this array. And in that array, for each new property you add, it adds a new object with the name, the type, and the value. Since we only have one new attributes and I don't really need to check for the name of it, I just decided to access the first element and access directly the value without having to check for the name. In case you want to expand this game further and want to use more custom properties, make sure to check the name first before accessing the value. Okay, so here I go, and then details. So we get the value, which is going to be the actual new camera position. If you remember here, when I click on the camera zone, CamPauseY is the custom property with a value, and that value is basically the value we want for the camera. And here we're going to use a tween. So a tween is a way for gradually changing the value of something using a function, a mathematical function, an easing function. Here we're using a linear easing function. So the tween in Kaboom.js takes 1, 2, 3, 4, 5 params. The first param is the original position, but actually no, not just that, the reference to modify the value. So the original value, but a reference to the game object or the thing controlling that original value. Actually, never mind. That's not true. It's here we do the modification. So the first param is the initial value. The second param is the final value you want, and the third param is on in how much time you want in how much time you want the transition to happen. So here I want the transition to happen 0.8 seconds from this initial value to this final value. And the fourth param is the function that will replace the gradually to the new value. So here val is called multiple times as following this function's pattern, the linear function. And for each call, it has an intermediate value between this and this that progressively gets closer to the final value. And here in Kaboom, to modify the camera position, you can also call the campause function and then pass in as the first param the x coordinate and the y coordinate. Since we only want to modify the y value of our camera, we will simply put back the same x value x position for the camera and just tweak the just set the new y position instead by using this. So value here. This is an arbitrary name. You could have decided to name it however you'd like. And then finally, k.easings.linear are the various easing functions you have access to. If you look at the documentation, you can have sign, sign in, sign out, etc. Linear is just the one I decided to use here. It's the one that looked good to me. All right, we have this. And let's go to room 1. And here again, we're going to do the exact same logic we did. So const cameras, and then empty array. And then here we can either do it like that. If layer.name equal cameras, what you're going to do is, or maybe you should do this here on top. It doesn't really matter that much in the end. So if the layer.name is the cameras, what we're going to do is we're going to push to the cameras array and spread from within layer.objects, which is again going to give us the collider, the collider data for the cameras. And then here, now for the actual usage, where did I use this? I'm just going to make a call to set camera zones, maybe right after this. Doesn't really matter. So I'm going to do this here. Actually, it probably is better to call this here. So set camera zones from here. K.map dot cameras. There we go. Okay, let's look at the results. Press enter. Now if I do this, the camera slides downwards. If I drop down, again, it follows everywhere. Maybe not the left hand side, because we only control the y position. We need to actually write the logic for the x position. So the x position, we just want the camera to follow the player, and that's the role of the first utility function that I was about to write is called set camera controls. So here, what do we do? The reason we need also the room data, because there's specific data that is going to allow us to bound the camera to certain limits. So here in room.utils, let me just check it out. Okay, so how we're going to do this is we're going to use a onUpdate method, Kaboom method. So onUpdate is called every 60 frames. It's where you can write more granular stuff. So here, if the state.current and then player in boss fight, then we return early. Well, why we do this? Because when we're going to have the actual boss fight, we want to make sure that the camera isn't controlled, is fixed basically to only the room, the boss battle room. Here I'm just going to import the state from the global manager. So player in boss fight, I think that was the state. Let me look. Is boss defeated? Player in boss fight. Yep. And here, player is in boss fight. I made a typo error. later on. So fix that in state global state manager. So here, if state.current, if player is in boss fight, we just won't run the logic, what comes next, because we don't want actually the camera to follow the player. And then the next stuff that comes right after, I'm going to copy and paste it, is if the map position X is plus 160 is superior to the player position, then we're going to clamp the camera position to be stuck at this value. This is so that when the player cannot go too much to the left, the camera cannot go too much to the left to the point that we can see outside of the bounds of the map. And then finally, the last if statement here we need is this. So if the player position.x is superior to the map position.x plus the room data.width, this is the actual width of the whole map, multiplied by the room data.tile width, which is supposed to be like 32 or 16 minus a certain value. This is what looked good. Then we're gonna clamp the camera, but to the right, so it won't go past a certain point to the right. And that way we will never allow the player to see outside the bounds of the map. And otherwise, if those conditions are not met, so we just make sure that the camera just follows the player from the x-axis, but the y-axis remains intact. So that's why I only modify the x coordinate and not the y. So for the y, we just take the current camera position. All right, let's check the result for that. So here we go. If I move to, maybe I should drop down. And then, okay, I forgot to actually call the function. So set camera controls needs to be called, and where we're going to call it is in room.1.js, maybe right after here. Okay, but this is an issue because the player isn't yet added to the scene. So we need to first wait for the player to be declared, and then we do this. So now if I look at the result, press enter, set camera is not defined. I forgot to import it here. Set camera controls. Now everything should work. So let's look at the result. Press enter, and now the camera follows us. That's nice. So if I drop down, it also follows us on the y-axis. So we cannot go past this point. We will never see the bounds, the outer bounds of the map. And then even if I go here, everything works all right. So yep, we have the camera now done, and this is not done. I fall. So that's something we need to fix. Why? Let me check. Let me debug. Why is this an issue? If I go here, we have a collider. We have a collider, but no body component. So we need to go back to VS Code, where we defined in Rumio.utils the set map colliders. If it's here, we forgot to add for the polygon colliders the body component with the isStatic property, because at the end of the day it's a wall type, it's an obstacle. So now if I look back at the result, press enter, and it should hopefully work. So here I drop down, and yep, it works. All right, we have the camera system up and running. That's great. We can pass through those platforms as well. Let me see if I can go back here. So now what is left is to do the start implementing the enemies. After the enemies, the boss fight, and after the boss fight, the linking with the other scenes. So for now, if I go here, there's nothing that happens, and I am out of bounds. So now it's time to work on the drones. So it's an enemy type that will follow the player and explode when entering in contact with the player. So in the entities folder, I'm going to create a new folder. I'm going to call it enemy drone.js. Here we're going to follow the exact same pattern I did for the player, which is create a function that is going to act as a constructor. I'm going to call it make drone. Here I'm going to, as the first param, set the context, And then as a second param, I'm going to have an initial position, because here we're just going to create the drone and set the position immediately. Then here we're going to return a make call, which is going to create the game object, but not add it to the scene. And then here we're going to have a bunch of components. So the positional component is important here with initial pause. We're going to need to have a sprite component. The sprite component is going to be the drone sprite with the anim flying. This was defined in the Kaboom loader function, by the way. Kaboom loader file, sorry. And then next, we're going to need to set the hitbox, so the area component is going to be used. Here we're going to have a shape with a new k.rectangle, and then k.vector2. We don't need an offset really. 12 by 12 would be a good hitbox. The anchor is going to be centered this time around, as I did with, I think we did the same thing for the player. I don't remember. And then here for the body, here things are going to be different. We're going to set the gravity scale. So gravity scale is another property you can set within the body component. And I'm going to set it to 0. So basically, we want our drone to have basically not be affected by gravity at all. So it's going to be floating around. I'm also going to use a new component that I haven't explained yet called the off-screen component and set the distance to 400. So this, what it does is that when when the drone is going to be off screen, so that means as the camera is scrolling and the player is moving around, let's say we have a drone that was following the player and then the player was able to get away, basically. And what we want to do is that if the distance between the camera, the screen and the player, the drone is at 400 units, I guess, pixels, whatever, then we're going to respawn. We're gonna not respawn, but reposition the drone to its original position. So here we're just using the off-screen component. Then later on, I think we're gonna use some of the event listeners that comes with it. So when you use the component, you have access to a bunch of methods that you can use later on. So not right now. And then here we're gonna play around with a state machine, which is basically what we're gonna use to code the AI. So I'm gonna explain what a state machine is in an instant, but for now, let me just teach you how to use the state component. So the state component starts with a first state. States here are just arbitrary names that you decide for yourself. I decided to create 1, 2, 3, 4, 5 states here, and I'm gonna paste them as to not waste too much time. So here are all the states I have decided to create, and you need to specify a default state, and that default state must be one of the states you have decided to create here. And the default state I'm going to pick is going to be the patrol right. So what is a state machine? So a state machine is a way for you to code an AI. So if I open up the Excalidraw and try to do a schematic, so we have, imagine you have a bunch of nodes. And then for each of those nodes, there are states associated. So patrol right. Okay, that's too big. Maybe okay. Zooming out. So I'm gonna just here. So we have our first state, patrol right. We have. I'm gonna just copy that around. Patrol left. Okay, that's kind of strange why it's behaving this way. Patrol. Okay, that's strange. Okay, my point here is that by having those names, you're able to define behaviors. Okay, so here, let's try to explain without the diagram. So those are names that are arbitrary. And for each of those names, we're going to define a couple of events that happens when the entity, the game object, will enter or be in those states. So here I have decided to name patrol right, patrol left, alert, attack, and retreat. And for each of those state that I've decided to name, I'm going to write logic that is specific to them. So when the drone enters a specific state, a specific logic is going to run while they enter in the state, while they're in the state, and when they get out of the state. Depending on the state we want, depending on the state, we're going to do different things. So let's just add the health component. I'm not going to re-explain here. We're basically setting the health for 1 health point for. Actually, did we set the health for the player? Did I do that? Yeah, we did. Okay. So just I'm gonna just set the health to be 1, and then add a tag to be of drone. And then here is I'm gonna do the AI coding, the state, etc. So you're gonna understand this more in a moment. Okay, so here are a few properties I want to define. So I'm going to have a speed of 100, a pursuit speed of 150. So this speed is going to be the one used when the player when the drone is following the player. The range is going to be 100. That's the range in which the drone is going to start is patrolling and is going to start following the player if they detect the player. And then here I'm going to create a method called setBehavior, and it's where we're going to define the logic related to the state machine. The state machine. So the first thing I want to do is I want to get the player, because I'm going to have to do a bunch of things, compare the distance between the drone and the player. And one way to do that is just to have a constant called player and then use the get function to get the player by using the tag. And as I explained earlier, since the player is going to be added or is already added as a child of the map object, we need to use recursive and true property, and so for it to work. And then here I'm gonna set we only want the first element. There is only one player. By default, get always gives you back an array. Okay, this is where things get interesting. Since we used the state component, we have access to a bunch of methods called the onStateEnter method. It's an event listener that you pass in as the first param the name of the state you want to define an event for. Here, patrol right. And then the second param is going to be the logic that is going to run when the drone will enter this state. So here, what I want to do, I'm going to use an async await here, because what I want to do is I want to await and then call the wait function in Kaboom. So here what it does, the wait function basically will wait 3 seconds before running what comes next. That's due to the await. So await, you have to wait for it before you can continue on. I'm not gonna dive deeper into the async await. I have done so in previous tutorials, so maybe reference that. I might write a post on this, but the reason we're using await here is specifically so that we wait those 3 seconds before running any other logic that comes after here within that function. Then we're going to have a check. So if this.state is how you access the current state, if that state is patrol right, what I'm going to do is I'm going to call the enter state method, again provided by Kaboom if you use the state component, and I want to enter the patrol left state. Now this might sound strange. You're already in the patrol right state. Why would you check that? Well, actually you don't know, because what comes after is another event listener, and this one is called onStateUpdate, and it runs every frame, every 60 frames, every frame. 60 frames per second. Yeah. I think every frame. All right. So here we have the onStateUpdate patrol right. So what is this? It allows us to create an event listener on a specific state while that will fire the second param, which is a function that is going to run all the time during the time that the drone is within that state. So here, so imagine this is while we are in the patrol right state, run this logic and it will run it every frame. So here what we're going to do is to have an if statement that will check this position distance. So dist is a method provided by Kaboom for vector2 components. It allows us to calculate the distance between one vector2 with another. So here, player.pos is the position of the player and is accessible because we imported the player here. And then if that distance is inferior to this dot range, that means we are within the range of the drone, and this time we want the drone to enter into the alert state. And then we return early. Otherwise, we want this dot flip x to be false. That means we want make sure that the drone is facing right, and then we want to make the drone move at a normal speed. So now I hope this makes a little bit more clear why we do the if statement here. Because when we enter the state, this runs once. And while we wait 3 seconds here, this is running multiple times because it runs every frame. So the situation can change, the state can change within this before we arrive to this line of code. So I hope you understand that. So just to repeat, here it runs once when the drone enters a state. Because it's the default state, this is also going to run once without having to call an enter state by default. And then here it's going to wait 3 seconds before moving on to this line. However, while we do that, this state update is running every frame. So in that time, during it runs every frame, the drone is moving as long as the player is not within the range. As soon as the player is within the range, we enter a new state. We enter the alert state. That means by the time that after the 3 seconds elapse, we arrive here, this state could potentially no longer be patrol right. Now we're going to do the same thing, but for patrol left. So I'm just going to copy and paste and mention a few things. So here we have patrol left, same logic, but instead of patrol left, here right it's left, and here it's left instead of right. And then here the only difference here is that we want to flip, because by default the sprite for the drone is facing right, so we want to flip it for it to face left, and we move to the left by adding a negative sign to the speed. So now it's time to define the logic for the alert state. So on state, when we enter this alert state, we want to run the following logic. We want to wait 1 second before initiating a pursuit of the player. Once we have waited, we want to check if the distance between the drone and the player is still inferior to the range. If that's the case, we can enter, we're going to enter the attack state. So attack is basically following the player. You could have named it pursuit instead. So attack state. And then we return early. Otherwise, we're going to enter the patrol right again and reinitiate the loop of patrolling normally. Left, right, left, right, left, right. So just to diagram this, imagine you have patrol right here. Hope this works now. We have patrol left. What's the issue? Okay. Okay, for some reason. Okay, now it works. So we have patrol right, patrol left, and then we have alert. So here's the alert state. Alert. And then we have the attack state. So maybe I'm gonna put it here. Attack. Whoops. So let's diagram this out. So initially we have the patrolling. So patrolling is basically going from patrol right to patrol left, and from patrol left to patrol right. However, sometimes if the player is too close, we go into the alert state. So while patrolling right or patrolling left, if the distance of the player is the distance is the distance if the drone is close enough to the player, then the drone will enter the alert state. And then after 1 second, if it's still the case, the drone will attack. So I hope that illustrates the situation. So we have that. And then for the attack state, we're not going to need to define an on state enter, but we only need to define the on state update for it, because we just want the action to immediately go, the movement, the following of the player. So here, if the player, that position, distance, and then player position, if that is superior to the range, that means as soon as the player is able to get away, is getting far enough away from the drone, we will enter back to the alert state. And then from the alert state, after 1 second, if it's still the case where the player is far enough, it's going to go back to the patrol right state. And then we return early here. Now, on the other hand, if this dot enter, so if it's not the case, wait a minute, no, never mind. So we return early, yes, but now it's time to follow the player to attack him. So this flip X is going to depend on where the player is. So we can just have this Boolean expression where we check whether or not the player position is inferior to the position of the drone. If that's the case, then it's going to be true. And if it's true, that means the player is to the left. So that means the drone should also be facing left. Same logic for the right. So if it's false, that means the player is to the right of the drone, and that means the drone should be facing right. And then here I'm going to use the move to method offered by Kaboom on on objects that have the body component. And you can specify destination. So here I'm going to specify vector2. I want the player position .x, but for the player position .y, it's going to be +12, just to have a little bit of a gap. And then I'm going to explain everything. Let me just finish typing and I'll explain things. So pursuit speed. Okay, what happens here? So move2 is the function from Kaboom. It takes 2 params. The first param is the destination. The second param is at what speed you want the drone to move towards. Here, instead of just taking the exact same position, having a bit of an offset makes sure that the player, the drone will actually, how do I say, will try to collide into to go outside of the player. So it's a bit hard to explain. Let me make a drawing. So by having the target here, so imagine this is a target and this is the player. By having the drone target this, we are making sure that basically if the drone arrives to the player, it's going to collide with the player. However, if we were to just have the exact same position here, so depending on the situation, the drone could stop just right here and remain here. So the collision would never end. That would be the thing, because you have on collide and then the collision would never end. Well, actually, never mind. It's not the collision would never end. Basically, I think that's the reason I did it initially. But thinking about it again, maybe it doesn't make any sense. So you know what? Instead of trying to justify it, let's just remove it for now, and then we'll see. We'll re-add it back when we see if it causes any issues. All right, so we have this, and then we have the attack, state, everything, and then that's it. That's basically it. That's the AI logic. Now we also need to set the events for it. So I'm gonna create another method called set events. By the way, set events, etc., and set behavior are just methods that I created, in which we use a bunch of methods offered by Kaboom. So for set events, I'm also going to have a reference to the player. So we're gonna have the exact same logic, recursive true. Remember that because the player is a child game object of the map. And then here we're gonna have this.onCollide, which is an event listener provided by Kaboom. When we collide with the player, we want a few things. So, whoops, not that. If the player is attacking, that means we want to return early. We don't want to destroy the player. That means we want this invulnerability to the player. If, however, that's not the case, then we first hurt ourselves, the drone, because the drone self-destructs and it has only one life. So using the heart method, which is provided by Kaboom if you use the health component. And then here we're gonna have a new feature in Kaboom called, well, actually we can, never mind. It's not a new feature. Here for the player, we can also call the hurt function and reduce the life by 1. Why we do this, how we can do this, because remember the player also uses the health component. That means it comes with methods to manage health. So here by calling hurt, it's a nice and easy way for you to deduct life from the player. Now here on anim end, again, another event listener provided by Kaboom. We want specifically to check if the anim that ended was the explosion, the explode anim. Again, these animations are all imported at the beginning of the project in the Kaboom loader file. If it's the case, we just want to destroy the drone. Now here, this.onExplode. So this is a custom event. It's a feature in Kaboom that I discovered recently and makes your code very, how do I say, more clean. So you can define custom events by using this on function. I have written a blog post about it. Again, if you're interested, I will put the link in the description, hopefully, if I don't forget. So yeah, and here, so the way you define custom events is you use the on method here, and then you decide on a name, and then the second param is what is going to run when this event is triggered. You can later on you use the trigger method to trigger a specific event. I'm going to show it to you. Here, I'm going to play a sound. So you play a sound by using the k.play function and passing in the name of the sound. So here, boom. Where does this come from? It comes from the Kaboom loader. We imported those sounds initially here. So here is all the sound imports. All right. Then what we want to do is not only play the sounds when we trigger this explode event, we want to also have a collision ignore. We want to avoid the drone from colliding multiple times with the player by just like removing any, making sure that any collisions with the player is avoided, is negated or ignored when the drone is exploded, because we have already deducted life points, one life point from the player, so we don't want to have a situation where we do this multiple times because the drone is still colliding with the player while it explodes. We also want to use the unuse method, which allows you to unuse a component that you added to a game object initially when you created that. So here you can just use a string and refer to the name of the component. So I want to unuse the body component. And finally, I want to play the explode animation. So here, be careful to not mistake this and this. This is for playing sound and is a method from Kaboom. And this is a method offered by Kaboom, but from the game object. So this is for playing animation, while this is for audio. Now here, we're going to have another onCollide here we're gonna have another on collide, and then yeah, so we have a sword hitbox. So this is the logic we want to run when the player hits with the sword the drone, and here we're going to do only hurt the drone itself. So by having the hurt 1 here, it's going to reduce 1 life point. Basically similar to this, but we don't have to worry about the player logic. And then here is when we define the... So here it's not a custom event. The hurt event is a specific already existing event offered by Kaboom. What it does is that it offers allows you to run something when you use the hurt function. So when I say hurt, when I call the hurt function, it's going to trigger the hurt event also offered by Kaboom. So here what I want to do is that when we reduce the life point of the drone, I want to check if this.hp gives you the current HP of the game object that uses the health component. If it's equal to 0, so if it's equal to 0, I want to trigger the explode custom event that I just created earlier on, which is going to take care of exploding, playing the sound, and making the drone actually explode with the animation, etc. And then that's it. One thing left is this on exit screen, which is offered by the off-screen component, allows us to have this method available. So when the drone is no longer visible on screen, if this.pause.dist initial pause is superior to 400, then this I'm gonna explain everything. This dot pause is equal to initial pause. So here what it does. Did I have the initial pause right defined? Oh, I made a mistake, a typo here. Initial pause position. So what does this do? Well, here is that when this will run when the distance, the player is off screen with a distance of 400. And then here, actually, I don't think you need to have this. You can just set the position to being the initial position, basically respawning the drone where it originally was. And that's it. That's the whole logic for the drone. So let's actually use it now. Let's place so here I'm gonna go in room1.js, and then room1.js, and then here, yeah, so for room1.js, for the positions layer, so here, so I'm gonna have a continue here. Now if the position.type was drone, remember for classes in tiled, you can access the name with the .type instead, which is kind of strange, but it's that. I think class is probably a reserved keyword anyway. So here, position.type equal drone. We're gonna create the drone game object, but place it as a child. Here I'm keeping a reference to it because we're gonna do gonna call the 2 methods we created. So here map add, and then here make drone, and then here pass k, and then position, and then here we need to pass a vector 2 with the position.x, and then position.y. And then drone.set behavior, which is the method we defined, and then drone.set events. All right, now that we have this, okay, Octet 2, I think the drone should appear in our game. So I'm gonna refresh, hit enter, and then we have a little drone. So let's see if we can, yeah, you see, that's the issue. That is that the drone remains kind of stuck above the player, but not exactly colliding fully with the player. That's why I added a initially here, instead of following exactly, I added an offset of 12. And now if we look back, if I let the drone come to me, it explodes, you see. So yeah, that's a quirk of the move to method in Kaboom, I think. And then we have another. Now let's see if I can attack this one. Let's see if we can attack. Okay, it's a... Yep, I was able to attack. So that's pretty nice. So now what's left is the boss. And after the boss, I think we're gonna display the cartridges, which are health pack. And then we link the two scenes. And then the game is mostly done, I think. We probably have to just add an intro and etc. By the way, if you cannot hear the sounds of the drone exploding, that's on me. That's my setup. Sorry. Maybe it's too late for me to verify if it actually recorded it properly. But yeah, just for your information, on my end, I can hear the sounds of the explosions when playing the game. So the first thing we're going to implement is the boss barrier. So for the boss barrier, we're going to go to the room 1 because it's something that is very exclusive to this room where the actual boss battle is. Now I think it was in the room utils instead, and here when I left it to do. So for the map colliders, so if we have the boss barrier map collider, what we're going to do is to have the following code. So here, so I'm first going to create a constant where I will hold a reference to the boss barrier. So first we create the game object that of course is a child of the map. Now here it's not that interesting, but okay, that's yeah, I'm just gonna copy and paste most of the concepts we have already seen. So here are the components we're going to use for this object. So a rectangle with a width and a height. The reason I'm using here the rect component instead of doing this inside of the area is because at one point we're actually going to see the rectangle. And we're going to set this color for the rectangle for the gate. And then the collider X and Y, and then ignore collisions with other colliders. And set initially the opacity to 0. And finally the boss barrier tag. Now we're gonna also have an object where we're gonna have a few methods. So the two methods we're gonna have is the activate method. So this is a method which takes care of, by using tweens, it's going to make the gate, the boss barrier, sorry, from invisible to visible. So here we're gonna first set the opacity from 0 to 0.3 in 1 second using the linear here. I have already explained how to use tweens here previously. Now here the tween is going to be the camera. So as we are changing the opacity of the gate, we're also moving the camera, so that we're gonna make the boss battle arena take center stage. And this is the reason I'm not using any await here, because we're doing this at the same time. So when you run this, because tween is asynchronous, it will run on its own, and then the code execution will continue to the next one, even though this is not done yet. So that's that. And then after this activate method, we're gonna have a deactivate method as well. And for this one, I'm also going to paste the code here. I don't think there's much need to manually type it. So here we have an async deactivate method that takes the current X position of the player. It will make the gate, the boss barrier, disappear. So here. and then it will move back the camera to the player's position. And then it will destroy the gate after after it has fully disappeared, so that the player can move out of the arena. And then here's some other logic we're gonna need. So here, this is within the boss barrier, but now we have also content outside of it. I mean, not content, I mean logic to write outside of it in an onCollide event listener. So when it collides with the player, we're gonna have it in a sync. And here, one thing in Kaboom.js is that when you use an onCollide with the tag here, onCollide will pass to the function you use as the second param the game object that is collided with, that the tag that the game object is colliding with. So here it's the player tag, so it's going to give you the player game object. So that means we don't have to use k.get here. So that's pretty handy. So here I'm going to first have a current state constant, just as a shorthand for this. Actually, it's barely less characters, barely less. Anyway, I'm just gonna keep it. And then here we're gonna have a first an if statement, and then if the current state is boss defeated true, whoops, if that's the case, then I'm gonna set a new state, so state.set. And what I'm gonna set is here this is where it's handy to have the state props enum. It makes things less error prone. I can immediately select the is boss defeated and then set that to being true. Or actually, it's not that. We want to set if the player is in a boss fight. So if player in boss fight, I should have named this is mid, but anyway, just to not generate any confusion, I'm gonna do this like that. So now I'm gonna set that to being true, actually false, because the boss has been defeated, sorry. And then we're going to make a call to the deactivate method and pass in the player position X. Now, after doing all of that, we return. So when the boss is defeated, we set back the players in boss fight player in boss fight boolean to false. We deactivate the boss barrier. Then if it was not the case, then we also need to check another case. If the current state dot player in boss fight, so actually if now the player is in a boss fight, we also need to skip, so we won't process the logic that comes after. So we have two cases that we want to avoid going further. The first case is if the boss is defeated. That means we just want to destroy the gate. However, if the player is in the boss fight, we just want to return early. So colliding with the boss barrier will do nothing special. So now the case here that we're gonna write now, the default case, is when the player first collides with the boss barrier. So when that happens, we are going to first disable the player controls. So this is something I did not write in the player logic, so I need to do that. So if I go to player.js, and then from player.js, let's write a method maybe here, right? Disable controls. And this is where we are going to use the control handlers that we had initially. So what I need is simply to have a for loop that will iterate through the various handlers that we stored in this dot control handlers, and then cancel them. So the way you do that is by calling the cancel method. By default, all of these handlers have access to that method. And then of course, don't forget to add the comma here. All right. So now we have disable control, and there's also another logic another method I should probably add is called respawn if out of bounds. So we want to make sure the player respawns if they fall off a platform. So here I'm gonna set 3 value, the bound value, the destination, I'm sorry, the destination name, and then the previous scene data. And by default, it's going to be exit name null. So this is going to make sense in a moment. So actually, for now, I'm just going to leave it to do. It's going to make sense when we're going to link up the various scenes with each other. So now I'm going to go back to the room utils, and then from there, after having written the boss player on collide, I can write. Okay, first I make a call to disable the player controls, because we want to basically force the player to go through the gate, and not arrive with a situation where the player doesn't avoids the gate. Basically, as the gate is sucking the player in, the player is trying to could avoid it and move to the other direction. We don't want to have this situation, otherwise you're gonna have a bunch of bugs. So by disabling the controls of the player and forcing him to go to the gate, through the gate if they collide with it, to go to the boss battle. And it's a bit like that in the Souls game. Once you commit to going through the gate, there is no going back, basically. And then I'm gonna play the idle animation while we do this. And then here I'm gonna again have an await for a tween, which is going to be responsible for changing the player position from this to player pause.x, but plus 25 pixels, so that we make sure that the player goes through the gate. We want to do that in 0.2 seconds. And here we have the value function that basically do the adjustments of the value until the destination is reached. And then here with an easings linear. And then once this is done, we are safe to do player.setControls again, so that we give back the player controls, the controls to the player. So this is a wait, so that as long as this is not done, we want to proceed forward. Otherwise, if you were to remove that, this would run while this would also run. So that means the player could escape and go out of the gate, out of the boss arena, while the transition would happen. All right. Now another one. So after having the onCollide with the player, the boss barrier, we also have the onCollide end. So not only can we in Kaboom.js know when you collide with something, but we can know when a collision ends with a game object as well. And then here, we don't really need to have the player game object here. What we want to do is that once the collision is over, first I'm gonna hold the current state like that, just for it's handier, I guess. And then I'm going to have current state, and then if the current state is a player boss fight, so if the player is in a boss fight, or current state dot so if either the player is in boss fight or the boss is defeated, so is boss defeated, then we return early. We don't do anything. And then otherwise we're going to set, so state.set, so state prom enum to make things less error prone. And what we're going to set is the player in boss fight, and here we're going to set it to true, so that the boss fight is actually starts, and then the boss barrier will activate, preventing any, what actually the activate does is just going to show the boss barrier. And then we're going to assign to the boss barrier a body component. So the way you add a component after the fact, after having created an object, you use the use method. And then here we want it to be static because it's an obstacle. And then here we go. And that's basically it. So now if I go back to the game and hit enter, and if I just go back to the boss arena, and then this is following me. Yep, you can see the boss arena is here, and I cannot escape. So maybe let me just retry this time around without activating debug mode so that you can clearly see. So here we go. I'm playing around. Then as soon as I hit, I'm transported and I'm stuck here. So now it's time to code the boss battle itself, so the boss itself. So how we're going to do that is we're going to create a new file in the entities folder. That file is going to be called enemy boss.js, and it's going to take the exact same, mostly the same properties, etc. So what I'm going to do is I'm going to copy and paste a bunch of stuff, but for now let's first write the constructor function. So make boss, and then pass in the k and the initial position. As for the components, we're gonna of course return a k.make, and then here for the components, I'm just gonna copy and paste the first few components here. So we have a state machine with different states. We have the idle state, the follow state, where the boss follows the player, the open fire state, where the player, the boss starts opening fire from their flamethrower, and then the fire state where it's firing, and then the shut fire when the animation to close the flamethrower will play, and then finally the explode state, which is where when the boss dies. And then here we have a mass of 100 and a jump force. Initially, I made the boss jumping as well, but I haven't used this anymore, so feel free to remove it. Here, it's again the same thing. Here, the animation is burner, the sprite, and the animation by default is going to be idle. And then the health, I gave him 15 points of health, and opacity initially it's 1. But as with the player, when the boss gets hit, it flashes, so it blinks. So now what we have here is our various methods. So first I'm going to copy and paste the various properties as well. So pursuit speed, fire range, and duration of the fire. And then right below, we're going to have the set behavior and set events. So set behavior and set events. Much of the same structure as I did with the player and the drones and etc. So here we go, and yep, I'm going before going onward, I'm gonna just define a reusable function that will make any game object blink. As I explained, it's when the player or the bosses or the enemies take damage, except for the drone because they immediately die when they jump on when they hit you. So, but for the boss and the player, there is some reusable logic we can write, and I think I'm gonna create a new file in the entities folder. I'm gonna call it entity shared logic.js. So what does this do? It will make gonna have a single function. I'm just gonna copy and paste it here and then go over it. So basically we have a make blink function that takes the context, the entity, the game object, and then its time span. By default, it is 0.1. You can specify a different one if you want. So it's an optional parameter. And then here, we use tweens to make first the opacity go from 1 to 0 in a certain time span, and then the reverse. So the first one is important to have await so that this doesn't run as this is running. But the second one, there is no need to have an await because it's the only thing here. So hope I made this clear. All right, so now for the boss, if I go to set behavior, I'm going to, actually, first of all, let's add the blink logic to the player. So in the set events here, I'm gonna add a bunch of events to handle that. So for the player, remember the heal and hurt events, so we can use that. So this dot on heal event listener is something that is offered by Kaboom if you use the health component on your game object. So here what I'm gonna do is I'm gonna set the health state as follows. So state props enum, and then here player HP, and I'm going to set it to the current, so this.hp of the component. And then I'm going to trigger, actually hit here to do health bar logic. So of course we're going to have a UI element that is going to update. So here we're going to trigger a custom event for the health bar. We haven't created the health bar yet, so that's why I'm just going to put a to-do message here. The other one, which is actually why I came in this file first, is because we wanted to make the player blink when they get hurt. So we're going to do that inside of the hurt event listener. That of course is offered because when you use the hurt function, the hurt method, to reduce the life point of the player, the health of the player, this gets fired. And here, this is where we're going to call make blink, and should normally automatically import it. So if you go upward, it should be imported. All right. So make blink is going to take okay, and then this, which is the game object itself, the player itself. And then here in this logic, if the HP, as long as the HP is superior to 0, so if the HP is superior to 0, I'm going to set the state of the state props enum.player HP, and then set to the new updated HP. So remember, the HP method gives you the up-to-date HP. Calling the hurt on the player fires this event, because not only the hurt actually changes the value, the health value, but also by having this event, we can make the player blink, but also make sure to set the state for the global state, so that when we move on to the second room, it's going to keep track. It's going to have the same health value. Otherwise, everything is scoped. So by default, the comp, the component HP health is scoped on the scene where the player is created. Actually, I think there is maybe a method called stay in Kaboom.js that allows you to have the same game object stay in the next scene. I haven't yet learned about it much, but I just remembered that it exists. So maybe we could have gotten away with not having to deal with global state like that. So something to check if you want on kaboom.js.com, which is the official doc site. Here we're going to also have a health bar update. So I'm just going to leave a comment here. And then we return early, because otherwise we will simply have the following code. So in case the HP is not superior to 0, I'm just going to copy and paste this part. We're going to set the state of the player HP to be the max player HP. So the reason for this is that we're basically respawning. Now you could put this later on. You could put this after, so that first you have the boom sound, then the explosion, then the health bar, the health of the player is set to being full health because they were going to respawn. And then right below that, this on anim end. Anim. Here we go. So if the anim is equal to explode, which was triggered here right above. Explode. What's with the weird spacing here? We're going to go back to the same room 1 scene. So it's effectively respawning. So I think we have this, and yep, we have everything we need. So let's save that. Let's of course save this as well. So now if I look at the game, press enter, let's see if we take them, if we blink, if the player is going to blink. Yep, they blinked. So as you can see. All right, so let's do the state machine for the boss. So much like the drone, it's going to basically have the same pattern. So a couple of this on state update or on state enter. So let's start with the idle state. So on state update we're going to need here. And then, so for the idle state, what we're going to do is make sure that if the state and then current. All right, so now we need to check for the current state if the player is in a boss fight. So state.current and then player in boss fight. If that's the case, we're going to move to the following. So enter state, and then we move to the follow. So this makes sense because when the player is not in a boss fight, so that means they haven't passed through the gate. We don't want the boss to do anything. We want it to remain idle. However, as soon as the player, enters the gate, this is set to true, and that means that it's time for the boss to start following the player. So here we don't really need actually, in fact, this shouldn't be a on-state update. It should be an on-state enter. So, oh no, it's an update because when the room is initialized, the boss is placed. So we need to check this every frame until it actually happens. The player actually enters the arena. All right, the next event we need to listen on is on-state, the follow event. So on-state enter follow. What we're going to do is we're just going to play the run animation. So here, so we have the play. Okay, so we play the run animation, and then for this on state update for the follow as well, the follow state, we're going to, in case you didn't copy, here are the various state we're going to use. So here, for the follow state, every frame, what we're going to do is we're going to first set the flip x value in much the same way we did for the drone. So if the player position is inferior to the boss's position, that means that the player is to the left, and that means that the boss should face left. That's why we do flip x equal true, because by default, the sprites are drawn facing right. Now here, this dot move to, so we're gonna use the move to again, as we did for the drones, and we're going to again do exactly the same thing. So move towards the player position with an offset of 12 here, so that we don't have this weird case where the player the boss will basically be stuck with the player, but nothing will happen. So then here we're gonna have a pursuit speed as well. Actually, in fact, I don't think it's needed here for this specific case, because at the end of the day, even if the boss gets stuck with the player can just move around. So yeah. Now the pursuit speed is the same as for this boss. For the boss, we only have a pursuit speed, so we don't have a normal regular speed like with the drones. And that's basically it for this logic. We also need to add an if statement, which will determine if we move out of the follow state. So if the position of the player position, no, if the position of the boss, sorry, is if the position of the player is near enough the position of the boss, and this we do this by checking for a specific range, so the fire range, so 40. So if this distance is inferior to 40 in this case, what we're going to do is we're going to enter into a new state, which is the open fire state. And then for the open fire state, on state enter open fire, and then what we're going to do here is just play the open fire animation. I made a mistake here. It should be lowercase. And now, after this animation is done, we're going to actually have an on-anim end here. But for now, we're going to have this on-anim end logic inside of the set events and not here. So let's continue defining our various other states, and then we will tackle this later on. So here we could have that this on state enter for the fire. So let's define the logic for the fire state. So what we're going to do here is create the flamethrower sound, which is going to be a reference to the sound of the flamethrower, which we can play like this. Remember, we imported this sound in the Kaboom loader.js file. Now, what we do next here is to have the fire hitbox. We need to create the hitbox for that. And we're going to basically add it as a child of the boss game object. And here again, it's the same logic we did for the sword attack for the player, just various different values here. So I'm just going to copy and paste that to go quicker. And then here for the logic for when the player collides with the hitbox, again, this is very similar logic that we did with the sword attack. But this time around we hurt the player, and then if the HP is equal to 0, we set the state. We set the player in boss fight to being false. That means that the player just died, and that means simply that they're no longer in a boss fight. And then here finally we have the k wait, which is going to wait. This is another form of the wait variant. So here I'm just gonna put the fire duration. So how long does the fire attack last? It's a property we created here, 1 second. And then we run this logic. So the second param is the logic to run. This is another form. You could have used a wait here and then did your logic right after here. But I felt that it wasn't really needed to use a wait here because we can just use this form. And then here what happens is that when the fire duration, so when the fire attack ends, we will stop the sound. So that's why I stored the sound here, the sound listener reference, so that I can easily use the stop method on it, which is offered by Kaboom as well. And then after we have stopped the sound, the boss will enter the shut fire state. Now for the open fire and shut fire, we haven't defined anything. For the shut fire and open fire, we haven't defined any on state enter or stuff like that. We're going to do this in the set events. We're going to actually just in our on anim and event listener, just run into enter those states. All right, so now let's define those. Let's define the remaining on state enters, on state end and on state update for the fire. So this on state end for fire state. So this happens here. And then inside of this, we just use that state to delete the fire hitbox. So as we did with the sword attack, you get the fire hitbox and then you check if it exists before trying to destroy it. And then finally, we have two things. We have the shut fire. So sorry, I was inaccurate later on. I said we wouldn't define a on state enter for shut fire, but we actually do here. We just play the shut fire animation here. And as here, the on state update for fire, this is useful to simply play the fire animation if it's not already playing as we go here. But here I realized that we could have just defined this here. So yeah, I think this is not a necessary state. We can take this line of code. I'm gonna just comment this out and I'm gonna paste it here. So we just play the animation of fire right here. And like that. So now let's go to our set events. Here again, we're gonna get the player. So as we did, oh, actually we didn't do this here. So const player k.get player and then recursive true, and then index 0. And then here we're going to define an onCollide here. So this time around it's the reverse. It's when the boss collides with the sword hitbox. We play the boom sound and then we hurt the boss, so we reduced its health. And this is an important part that I referenced earlier on. We're talking here about the this on anim end. We're going to use a switch case statement here. So if we are in the open fire state, we enter the fire state. So here open fire, if I remember correctly, we just play the open fire animation. This open fire animation ends. It's not an infinite loop. The loop property wasn't set to true there. If you look at the Kaboom loader.js file, if you remember. So if we go here to the boss, the burner, yep, is the boss. So for open fire, there's no loop set to true. So that means that the animation plays once and then when it ends, it ends. That's why we can use in our code here, where is it? Where is it? Here. That's why we can use here the on anim end listener. So we do the same thing for the shut fire here as well. So when the shut fire animation ends, we enter the follow state. And finally, when the explode animation runs, after it runs actually, we call the destroy method function from Kaboom to destroy the boss. So the boss has been defeated. And then right below that, this is where we're actually going to define a custom event called this on explode. This is exactly the same thing we did for the drone enemy. So here we enter the explode state. Now here explode state, we haven't defined it, I think. Did we do? So the purpose of this is just to have a state that is different than what is the other states. So it doesn't do anything really, but yeah, that's that. It's just so if we weren't to do this, it would the state machine would enter other states and then it would conflict. So by having a dedicated state, useless state, quote unquote, we were able to not enter this case. And remember that here the explode, you need to add it as well here in the state array at the beginning. So what we do here, we set collision ignore to the player for the same reason. We unuse the body, we play the boom sound again. We play the explode animation, which after it's done, it's going to destroy the enemy, the boss. We set the is boss defeated true state to true. We set the is double jump unlocked to true. And then here I have enable double jump method. We haven't written this, so let's just write it out quickly. So it's a one line method. So I'm gonna put it maybe at the end of the player. So let me collapse this so it's clear like that. So enable double jump, the way you have access to the num jumps property if you use the double jump component, and you can set it to a number you want, and here we're going to set it to 2. So now if I go back to enemy boss, it's going to do that. We're going to play the notify sound, which is a sound that basically will display this notification box. Now make notification box does not exist yet, so let's create it out. Let's create this UI element. So I'm going to go here. I'm going to go to the UI folder, which is empty, and I'm going to create a new file. So this file is going to be called notification box.js. And what it's going to contain is the following. So we first have as a first param the context as always, and the second param is the content. Then here we're going to make a game object, which is going to be a rectangle, and with a darkish blue or purple color. And then we're going to use the fixed component so that it is not affected by the camera. We're going to center the position by calling k.center, which gives us the coordinates for the center of the canvas. The area component is important here because we want to set the anchor as a center, and the method we're going to use is create is simply a close method that just destroys the notification box. And then as a child of that container, because initially it's a container, we're going to put a text component, so a child game object that is going to have a text component that is going to use the glyph mess font that I showed you at the beginning of the tutorial, and the size is going to be 32. This is what looked good. As for the color of the text, this is what looks good and fits with the color palette. Here, area and anchor center again so that the text is centered. And then we return the container. So that's our notification box. If I go to the enemy boss, here you can see the text I have put. You unlocked a new ability. You can now double jump. And then after 3 seconds, we're going to call the close method that we defined here so that the notification box is closed. So here we just add it to the general canvas instead of the map because it's a UI element. And we just store it here so that we can have access to close. We can call the close method. All right, now let's import that properly because it didn't do it for us automatically. So here, import make notification box. Remember to add a .js, otherwise you're gonna get a MIME type error. And and that's it. So now that we have that, I think we have everything we need for the boss, and it's now time to test it out. So let me just make sure that's the case. We have one last thing, one last event. So the hurt event for the boss. So as I explained multiple times now, the hurt event is something offered by Kaboom if you use the health component. And here we're going to make blink the boss. If the HP is superior to 0, though, we return early, as we don't want to trigger the explode event, which will take care of destroying the boss. All right, and let's import that also. Import make blink. And that's it. Yep, that's the whole logic. So now in our room1.js, so in room1.js, if I go to the positions here, and then here I'm just going to add a continue. So the reason I'm adding a continue here is that if for this position we enter here, there's no point in running the other if statement that comes next. So because we already know that it's a drone here for this iteration, so we need to go to the next iteration to have to check for the other entities. So if the position here, name, and then here I think it was boss. Yeah, if we have a boss, and of course we only spawn the boss if the state dot current dot is I think is boss defeated is false. So only if the boss is not defeated that we will spawn the boss. And here const boss, we add it as a child of the map, and then we call the make boss. Now that we have the make boss, we just put here k.vector2 for the position. Whoops. I can't seem to write it well. And then position X, position Y, and here. And then finally we call boss set behavior, which is going to set the AI for the boss, and the boss set events, because it's going to set the various events for it. And that's it. And also for the cartridge. So the cartridge are basically health. But before doing that, let's just test it out. So if I look, refresh, state is not defined. Okay, where is that issue from? State not room 1. Okay, we forgot to import the state. So here, let's import it here. Import state. Here we go. Now, if I refresh, press enter. Okay, okay, I forgot vector 2. Room 1, line 64. Line 64. Yep, I made a stupid mistake here, a typo. And then if I press enter, what I mean state is not defined. We're in enemy boss. Forgot to import the state here as well. So import state. Hopefully now it works. Press enter, and yep. So now let's play through the game. All right. Let's see if we can fight the boss. Player is not defined. Come on. Player is not defined. Enemy boss line 35. Okay, line 35 for the enemy boss. Where's that? Player to position. Okay, I guess I should have const player equal k dot get player recursive true, and then here we go. And then now if I play the game, normally everything should work all right. And then here we go. Yeah, the boss seems to work. Does he follow me? Yep. State prop enums is not defined. So this is probably again in the enemy boss. State props enum. Here we go. So if I fight the boss again, here we go, and then I move forward. There you go. All right, you unlocked a new ability. You can now double jump. And now I can indeed double jump. So, okay, so the game works all right. Now what we need is two things. We need the health bar. And we need to do the health bar. And then after that, we'll add the cartridge. And then after that, the only thing left is really the rooms, the second room. So for room 1, actually no, for the UI, I'm going to create a new file. I'm going to call it healthbar.js. I think it would be better to just tackle the cartridge. So for the cartridge, what I'm going to do, cartridge are basically health packs, and we can just go to room1.js and then add a simple if statement here again. It's a single line. If the position type is equal to cartridge. Actually, we're gonna need to create a new entity for that. Map, add, and then we're gonna add the cartridge here. So in entities, create a new file, call it health cartridge.js, and then here in health cartridge, we're gonna have a simple component here. Let me just explain. So make cartridge the constructor, okay, and then the position, and then the position is just set here. And then we use the sprite cartridge with the default animation, and then we set the on collide with the player, and then every time the player collides with the cartridge, we play the health sound with the volume of 0.5 because the original sound was too loud. And then if the player HP is inferior to the max player HP, we allow a heal. Otherwise, we do nothing. We don't heal. And either way, we destroy the cartridge. So if I go to room 1, now call make cartridge, pass in k.vector2, and then position x, position y, and then that should be it. So if I go and test this out, we have our cartridge here. Let's try colliding with one, and you hear the sound. So there is not much. Let me just test something. So there isn't much to do here to test without the health bar. So the health bar is really key now. So I'm going to go back to healthbar.js, which we created here in the UI component. And then health bar is basically simple as well, and not a lot of line of codes. So I'm just going to copy and explain everything. So we have this constructor which is makes this health bar component, uses this health bar sprite, sets the frame to 0 because we have 3 frames. We don't have any animations for this one. As if you remember earlier on in Kaboom loader, what we had here in the sprite atlas was the health bar with a slice y of 3. That means that we have 3 frames. So in Kaboom.js, you can just display a specific frame by using the frame property. So that's what I did here, the frame 0. And then here I scaled it 4 times because this we actually scale the camera, I think 4 or 2 times. But for the UI to look good here, we need to scale the sprite 4 times. And here the HP mapping just tells you that for any amount of health, so one amount of health, we need to display the frame 2. For 2 health point, we need to display frame 1, and for 3 health point, we need to display frame 0. The reason this makes sense is simply that if you go to the UI.png, you can see that this is going to this is going to be frame 0, frame 1, and frame 2. So when we have full health, we have actually the frame 0. And yeah, frame 1 is when we have 2 health point, and frame 2 is when we have 1 HP left. And then here, that's why I created this mapping, so we can easily set it here. So then I called the set event listener. I created the set events method, which is where we define this custom update event. And then what it does, it takes the current HP, and then if the current HP is equal to 0, we destroy the health bar because we're gonna just recreate it. And regardless, we set the current frame to be used to being the current HP mapping. So here we go. So this makes a bit less sense because you could maybe just go here. If you're gonna destroy the health bar, might as well not do that. So it becomes pointless to set the frames afterward. And then we're just gonna create one health bar here that we use here. So instead of creating that in our various rooms, we just create one here and we import it where we need it. So let's add this to room1.js. So we're gonna add it at the end of our file here, actually outside of the for loop. Health bar, then we set the event, which is just one. We call the trigger, we actually trigger the update event once. Health bar dot trigger the update. And then of course remember that we need to actually add the health bar to the scene because we have only used it with make, so we haven't added it anywhere. in the canvas yet. All right, so now that we have that, if you remember earlier on, I had two to-dos. So to do. No, not that one. Health bar. Come on, I had a comment to do. Did I forget about this? Seriously? Okay, never mind. Never mind. So I think it was in the player logic, in the events for it. Yeah, okay, so it was here, health bar. So here we're just gonna call the health bar and then trigger an update. We're going to do the same thing here as well. So now if I look at the result, press enter, we have our health bar. Let's take some damage just to test things out. And then you can see our life is reduced. And then when I get healed, damaged again. And then let's get damaged again. And then let's let this droid kill us. Here we go. And then we respawn. All right. Sounds good to me. And yep, so the game is basically done, except now we need to have the other room. So yep, let's work on that. All right, so one quick thing we're gonna do before proceeding on to writing the logic for the other room is we're just gonna write some logic that when the player falls here, so after a certain Y position, they respawn. To do something like that, we're gonna fill this function that I left as a to-do. So the way we're going to go about it is the following. So if respawn if out of bounds. So here I'm going to create a onUpdate loop. This onUpdate loop, what it's going to do is it's going to check every frame if the position of the player. So here I'm in player.js in this method that we wrote but didn't write the body of previously. And then here, so if this, so this is the player, the position Y is superior to the bound value, which is going to be the maximum Y position we want to allow, then yeah, superior. So remember, in a canvas, in GameDev usually, the farther you go down, the higher the value of Y. That's why we have this statement here. So now what I do is that if the player exceeds this bound value, we can just go to the destination name, which is going to be the room you want to go to, that we're going to define later. And then we're going to pass the previous scene data as the other. By the way, the go function in Kaboom.js allows you to switch to another scene, but it can also take in addition to the name of the scene you want to go to, you can pass some data. And here the data we're going to pass is going to be the exit name. So here in our what is exit name is going to refer to the exits of the that we had on our map. So here the exit layer in tiled, you have exit 1 and exit 2. So the way we're going to go about this is we're going to use this previous scene data to tell Kaboom when to spawn, where to spawn in the other room. In this particular case, though, what we do is that we're not going to add anything. We're going to make the exit name null because we want to just respawn in the current scene. So here it doesn't make much sense for now, but bear with me. So here, it's time now to use the respawn if out of bounds. And we're gonna call this inside of the room1.js. In this file, I'm just gonna have the player here, player respawn if out of bounds. All right, so we have this respawn if out of bounds. So what we're gonna do now is we need to actually pass in the params. So I'm just gonna pull the player.js file for reference because I need to find it just to know what to do. So the bound value, I think the bound value I did in my original was 1000. So 1000 will be the maximum y value we want to allow. Otherwise, we would spawn into room 1. So what we want to do here is to set the respawn if out of bounds value, the bound value to 1000. This is what looked good. And then immediately go to room 1 if we go out of bounds. So let's try it out. So if I go here, okay, it's not a function. Why is that? So here, respawn if out of, I made a mistake here in player.js, of bounds. Now everything should work, so let's try it out. Now if I drop off, I should respawn. All right, everything is working nice. So now we have finished every gameplay features. And now what is left is just to make the scene transition to the other room and repeat some of the logic for the next room. So room 2. So to be able to pass data between the scenes, as I have shown initially by using this second param to the go function, we can actually receive that data. We haven't written the logic for it. So if I go back to main.js, you can see that we just pass the room 1 data here, but the room 1 data, we can receive it here. So if I go to main.js, I can create a param here called previous scene data, and then I can just decide to pass this as a third param to this room 1, and I'm gonna have to, of course, create a new param here for the room 1 function in our room1.js file. So this can be passed by the go function. By default, we want to make sure that this is null. So you have to specify this by default. We could have decided that here by default, if it's not, never mind, you have to. So by calling k.go room 1 to go to the room and specifying an object as a second param, it's going to be our previous scene data. So this refers to this. All right. Now you can see that for our case here, we haven't had anything here. So let's set the data we want to pass as exit name null. We're just coming from the menu, so there's no previous exit we're coming from. But this is going to be useful for room 2. So here I'm just going to pass the exact same data, but just instead of room 1, it's going to be room 2, and then previous scene data here as well. And now we need to actually write the code in room2.js, which is pretty empty for now. We're going to have to do basically the same thing. So set the background color with the color I specified previously, which was hashtag A2AED5. Remember to add the .js to the import the statement. Make sure to cam scale 4 times, like we did in room 1. Make sure to add to set the initial camera position to 170 by 100, like the initial camera position we did for the room 1, and then set the gravity as well to being 1000, like we did with the first scene, the room 1 scene. Then we're gonna get the room. I'm gonna store the room layers inside of room data dot layers. Actually, we're gonna store the layers inside of the constant room layers. Sorry. And then we're gonna do the same thing we did. So create a map game object, add it to this scene, and then set the position to being 0, 0 as a reference, or just you can easily modify it later on, and then set the sprite to being k.sprite, and then room 2. Remember, we have this loaded from the Kaboom loader.js file, and that's basically it. So now if I okay, yeah, so that's basically it. Now we can do I'm just gonna copy and paste the exact same logic we had here. So I'm gonna take room 1 and then copy all of these, and then all of these as well, and even the player as well. So really everything comes except for the there aren't any mobs. There are cartridges, so we're just gonna modify a few things. So let's copy all of that and then go here and then paste it right below. Now, of course, there's a bunch of import statements that are missing, so we're gonna have to figure this out. I'm also going to remove the drone here because there are no drones in this room, and also the boss. So what is left is the cartridge and the player. And then here we're gonna have to import everything. So let's import import the player, the make player, sorry, function. Let's import the make cartridge function. We also need to import the state. Do we use the state here? I'm not sure. No, we don't. We actually need the health bar as well. So let's import that as well. Health bar. And then, okay, we have the health bar. We have everything. And then the various set camera zone, map colliders, etc. So here again, I'm just gonna go here to the room1.js and copy and paste this from room utils. So take this import statement, paste it here, and then save. And then I think we should have everything we need. Let's try it out. So what I'm gonna do now is I'm gonna actually have to set the exit zones now. So one thing that we didn't write in the room utils is a function to handle when you exit a given room, etc., etc. So right below set maybe at the end of the file, I'm gonna go to room utils and then create a new function, export function, and then this function you're gonna call it, as I said, set exit zones, and then it takes the context, the map game object, the exits, and the destination name. I'm gonna call it this way, this pair. All right, so here so where does this exits come from? So here in our room 2, there's another layer we're gonna look for is the exit. So I'm gonna add right above here if the layer name equal exits. By the way, we need to also add this in the room 1 logic because there are exits as well. So let me just verify here. So we have the exits layer. So now we're gonna create a new array. So you could also like make this more modular. So all this part that we copied and pasted from room 1, you could have a single source of truth. So a big function that does all of this. I didn't do it for this project because it's a relatively small scope, and in case you want to push this further, I recommend that you start modularizing and abstracting things from here. So here we're gonna have the exits array that I'm gonna create, and then in the exits array here I'm gonna push exit.push .layer.objects, just to not have an error later, and of course continue, because otherwise there's no point in running the last if statement if we arrive to this condition. So you could have decided also to have this as a switch case statement in hindsight, so feel free to refactor. So I'm just going to copy that part in room 1 as well, and now we can go back to room utils and then go back to the set exit zones. So for set exit zones, we're going to iterate through the exits. So exit of exits. And then we're going to create the exit zone game object, which is a child of the map game object. We're going to set the position to be exit X, exit Y, because they offer the position. So yeah, so we have the positional data inside of this exit constant. And then we're going to have, now I'm just going to copy and paste because it's roughly the same thing we've you've been used to with the other ones. So the area is specific. We ignore collisions with colliders, and then we pass in the exit name. This is important because this tag is unique to the exit name. So here, for exit 1, this is going to be the tag. For exit 2, this is going to be the tag. And then for here, room 2, the exit 1 here, exit 2, and then final exit as well. Okay, so now that we have that, right below, we can set a collider on collide event listener. So if the exit zone on collide, so collides with the player, we're going to have the following. So we're gonna use an sync function here, and I'm just gonna copy and paste the code just to go a bit faster, and then I'll explain it every line. So what do we do here? So we set the background. So this to have a nice transition. So we create a rectangle that takes the whole screen that will move via a tween. And then if the exit name is the final exit, we go to the final exit scene. We haven't created that scene yet. So just copy and paste that for now. Otherwise, we go to the destination name, which is either room 1 or room 2, depending on where you're coming from. And we pass in this object to that next scene, which is going to tell us the exit name we're coming from. That way we can know where to spawn the player, either in entrance 1 or 2. So we're going to have to add some logic to room 1 and room 2.js to control the spawning of the player. So now that this is done, we are ready to use it. So in room, let's add it to room 1 and then to room 2 as well. So for room 1, I have added it here. So let's do it last, or yeah, we can do it last. It doesn't matter. Okay, let's do it right after here. So right after the camera control. So set exit zones, and then pass in K, the map, the exits, and then the destination name is room 2. In room 1, we need to take this same logic in room 2, but instead of room 1, instead of room 2 here, it's room 1. And now here in room 1, let's go here. So for the player position, actually it's going to be a bit more complex than only one if statement. So if I go back to the player, the room 1 logic, so we're here, we're gonna have two other if statements. So for the first one, we're gonna add the condition that if the previous scene data was null, that didn't exist. Actually, we need to do if the exit name is null. So we would spawn the player in the original initial position. Otherwise, if the position.name is entrance, so yeah, so we had a pin. If I go here, if I go to the positions layer in room 1, so I'm just gonna make it visible. We have this entrance 1 and entrance 2 pins. This is where we determine where to spawn the player if they're coming back from a scene. So for this if statement, if the pin was entrance 1, so the position was entrance 1, and we had a previous scene data exit name passed through this to arrive to room 1, and it's exit 1, then we would place the player into the position of that pin, and then continue on, and then set the camera position to be the one of the new player position, because otherwise the camera would still be up there in the level. And then finally, exactly the same logic. So here again, I was at the end of the project, so I just wanted to get it done as quickly as possible. So there's a bunch of repetition, but at least with repeating code that is simple like that, it's easy to abstract it when you need it into a more reusable version. So here is the same logic. All right, now we do the exact same thing in room 2. So for room 2, I'm just gonna copy and paste the logic, but this time around, we only access room 2 from either of those two exits that you saw initially. So we don't need this default if there's no default spawn point for room 2. So it's either entrance 1 or entrance 2. If you look in tiled, room 2, you can see the player can either spawn here or there, or there. There is no two options, sorry. So here the same logic. This time around, we set the position as the, never mind. So why is this the case? Map position.x. I don't think we actually need that. So if I go back to room 1, I just set the position normally. Since we have the player as still a child of the map, we can remove this. This was an error on my part because the position is already relative to the map anyway. So let me just remove that. Hope it will work. And here we go. So hope I was clear. If there is anything unclear, feel free to comment in the comment section. Ask your questions there so I can see them. All right, I think we're basically done. Let's try it out. So there's an error already. So set background color, room 2, probably missed an import statement. Set background color. What's the issue? A redeclaration of import set background color previously declared at line 1. Okay, right. So it was redeclared at line 3 or 6. Ah, okay, I see. I copied it twice, so I'm just gonna remove the first one. Now if I press enter, exit is not defined. Okay, line 40 of room 1. So line 40, it's not exits. I thought this layer existed. Let me look it up. Exits, yes, this layer exists. Did I mess something up? Layer name. Exits.push. Ah, I forgot to create the original, the array for holding all the exits. So let's do the same in room 2 because we're gonna have the, okay, we did it for room 2, did not do it for room 1. That's why. So if I press enter, and then we have our game. Okay, now let's test it out. So I'm gonna just go to the left, and we have previous scene data is not defined. Okay, where's this error from? Main.js. Okay, main.js, previous scene data. Okay, we need to pass this here. So now it should work. Let's test it out. Pressing enter. Here we go. Now let's go here. And then K is not defined. Okay. So what's the error now? K is not defined in room 2, line 12. Room 2, line 12. So room 2, line 12. Okay, we didn't pass in the K here. And we didn't pass in the room 2 data as well. And we didn't pass the room data as well. And we didn't pass in the previous scene data. So forgot to add all of these params that we did for room 1. Now it should work, hopefully. So I'm gonna make this full screen. Set exit zone is not defined. Again, forgot this in room 2. Let's add it to set exit zones here. Did we add it for here as well? Okay, for room 1 and room 2 we have them. So now let's test it out again. And now it should hopefully work. And it does. And then if I exit back in, we're back at the correct position. So now I'm just going to go to the other one. So actually I have to beat the boss first to unlock the double jump ability. Okay, let me just hit the... Let me just beat it and then we'll... Alright, now we should have the double jump unlocked. And now I can go to the other side here. And we spawn in the correct place. And now here, it's normal if it bugs here because the scene doesn't exist. Or did we actually create that scene? Yeah, final exit, we didn't create it. So the game is mostly done now. The only thing left is really to create those last scenes. So the intro scene with a message that tells you like how to play, and the final exit scene. So we're gonna do this in main.js. For the final scene, I'm just gonna create it here, right below the intro scene. And then I'm just gonna make a call to the notification box with this message. I'm gonna do the same thing for the intro scene and the project is done. So here, I'm gonna import make notification box. And then for the intro scene, I'm just gonna add the following as well. So right below here. And then one thing I also want to add is, I'm not sure if it does anything, but the audio on the web page, unless you do a gesture, the audio will not activate. So if the first sound of your game is a sound effect from getting hit, and before that there were no sounds played, then it's going to have a lag between the time the sounds actually play and what happens on the screen for the first sound that is heard on a web page. So I thought this would fix the issue, but I'm not sure if it does anything. So I'm gonna keep it here. So it's about creating a new audio context, but I'm not sure if that it works, because we should actually resume the already existing audio context, but I'm not sure how to get access to that. So this is something with Kaboom. I don't know if there is a fix, except that you start immediately playing some background sound when you, or in the menu playing some sounds. That way you wouldn't have this issue. All right, let's test it out. And okay, set background color is not defined. Import set background color. All right, the game should be done. Let's play it. So escape the factory, use the arrow keys to move, X to jump, and Z to attack. And then press start. So let's play. Let's see if everything works all right. So I hit the enemy. All right. I took some damage. Can I go to the left? Yep. By the way, this is intentional that the enemies respawn when you go to another room. That's a bit like in Souls games. The enemies respawn like that. But so I'm just gonna beat the boss, and once the boss is beaten, okay, I have unlocked the ability. By the way, you can make the boss more complex. I made it simple on purpose so it's easy for me to play test. So now I'm just gonna complete the game. So here, go here, and then I took some damage, and then I go to the left side, and then I jump here, and I jump here. And by the way, I'm just gonna drop off here to test that the respawn logic works. Yep. And I'm just going to also go back here to make sure that the logic works. All right, it does. And then I'm just gonna finish the game. You escaped the factory. The end. Thanks for playing. And that's it. That's the game. Hope you enjoyed this tutorial. And by the way, if you want, you can subscribe to the channel so that you don't miss out on future tutorials. I don't upload that often, so it would be a good idea. But yeah, so I hope you enjoyed the tutorial, and you can go on my channel, see other GameDev, JavaScript related tutorials. Thanks for watching. Bye. One last thing, if you ever want to upload this game online, what you do is you just zip the whole code base and then drag and drop it on itch.io, and it should be able to deploy. That was one thing I forgot to tell you. So same thing for GitHub pages. You just activate GitHub pages on the repo for this project, and it should be up and running. So that's the advantage of not using a bundler or NPM, is that the deployment is very easy. All right, thanks for watching again. Bye.